So expectations for today, we hope that you have some familiarity with Linux, also that you maybe work for a network engineering team, whether you're a sysadmin, DevOps, solutions architect, maybe you're a developer, maybe you're a PM that's looking to evaluate NGINX as well. And we do hope this is an advanced level course, so we do hope that you have at least completed NGINX Core, which is our entry level course, or that you have some familiarity with NGINX already. It would help to have a solid understanding of network topologies. So, for example, if you know how to set up a high availability pair of web servers or websites, or if you know how to work with a hardware load balancer such as F5 or Netscaler, that would be also helpful as well, just so that you understand some of the concepts we're going to talk about today. Now, in terms of the training environments, you should have host names for a total of, I believe it's 7. The only 4 that you're going to be interacting with today are the NGINX instances. We have 3 Tomcat, I think they're actually Tomcat 8, not Tomcat 7. But we have 3 Tomcat 8 servers that you're going to be using as your backends. We're not going to SSH into those instances. They're just there to, have something to reverse proxy against. But the 4 instances that we're going to be using today, I want you to start out with the host 1 instance, which should be in the email that you received last night. You should also have access to an Elastic IP address and also an Elastic IP allocation ID, which is an AWS thing. If you don't have those or you can't find them in the sheet, I can pull up an example of what mine looks like. But I also have a master list for everything in case you haven't found it or you didn't get the email last night. So having said that, let's go ahead and SSH into our host 1 instance. So for those of you using a Mac or Unix environment, you're going to use the SSH client that comes with the operating system. So for example, I'm using a Mac, so it's going to be the terminal application. For those of you who are using Windows, it's either going to be PuTTY or Bitvice. And basically what you're going to want to do is for your connection type, you're going to want to choose SSH. And basically you're just going to use the student name, which, it'll be student and then some kind of number, and then @hostname. And then once you use that as your SSH credentials, it will prompt you for a password, and then you type in the password and you should have access. So I'll give you guys about 5 minutes to get in. Let me know when you're ready to go. And I should actually take this time to do it myself as well. So let's see.
James, you said we need to have access to 7 instances. I only see 4. Is it because the 3 upstream instances are not relevant, or?
Yeah, they're not necessarily relevant for SSHing into, but we are going to put them in our upstream config. So those aren't as important as the other 4.
Thank you.
All right. So let me grab my information. Okay, looks like Martin's ready. And if anyone's having problems with their machines, like the password's not working or something, let me know and I'll test it out. And if it doesn't work, I'll try to spin you up a new one on the fly. So for mine, I am student 1, at least for this instance. And let me grab my host name. It's also going to probably ask you if you want to add the fingerprint. I guess you can do that if you want, even though these are ephemeral instances. And then it's going to ask you for a password. Okay. So it looks like I'm in the box. Once you're in, you can do NGINX-V, and you should see that we're running the latest version of NGINX Plus, which is the R14 release. Okay, it looks like all of you are ready. Great. You guys are rock stars. Give me one moment. Okay. So now that you're in the VM, let's do some course administration today. So the course is going to take about 4 hours, give or take how long we take to go through the exercises. We will have a 10-minute break at the top of each hour. That's a great opportunity for me to help anyone if you're having issues with the labs. But in terms of questions, feel free to interrupt me at any time, either in the chat window or with your microphone. And I do encourage you to ask questions because you'll probably get the most out of your training depending on how engaged you are. Just to give you a little information as to how the 4 hours are going to break down. The first part we're going to do is it's mainly a review. So it'll be 15 minutes. This will pretty much cover the whole gambit with regards to NGINX core. So it will be very accelerated, and I don't want to spend too much time on it because we assume that you already know at least a little bit about NGINX. Then we'll jump right in. So we'll jump right into the layer 4 features of NGINX, which aren't necessarily covered in the core class. So this is basically your TCP and your UDP load balancing scenarios. Then we'll talk a little bit about advanced caching. And I know you may be wondering, okay, this is an advanced load balancing course. Why are we talking about advanced caching? And that'll make a little bit more sense once we get to that section. But basically, we're talking about ways to increase performance of your load balancing tiers. And one of the ways to do that is to set up an advanced caching tier, which also includes an upstream configuration that you need to configure. And then finally, we'll talk about high availability. And this will kind of be the crescendo to the entire piece. I will take the longest because we're going to have to be using some AWS resources to get this to work, as well as a Keep Alive D implementation of NGINX. But once you learn that, you'll pretty much be ready to do anything from an enterprise level on how to make NGINX scalable and fault tolerant. Okay, so let's quickly go through the load balancing review. And for those of you, maybe you'll find some new information in this, but maybe a lot of you, this will be review. The point of this section really is to just do an overview of the configuration and how it works, as well as discuss the selection algorithms. We'll also talk about the hardware migration, if some of you are. And actually, that's a good question. So how many of you are here because you are actually migrating from a hardware load balancer? And I guess if it's no one, then I know how to go. I know I can go through that section quickly. Okay, so it doesn't sound like that's anyone's use cases. Maybe while we're on the topic, what are some people's use case? If they want to type it in the chat window. Do load balancer for production system. Okay, on HTTPS, great. Anyone else want to share? Looks like someone raised their hand. Maybe that's what they were saying. Okay, so got it. Cool. Okay, last thing I want to mention here is we are going to talk about the extended status module, or at least that's what it used to be called. We have a new API module that allows you for some advanced monitoring with your NGINX configs. So we'll talk a little bit about that as well. So some of the load balancing components I want to go over here are the selection algorithms, the upstream directive, the proxy pass, and the health check. These are pretty much the core things you will need for a load balancing config. Here's an example of what it may look like. So here's an example of an upstream. And an upstream is pretty much defined as a pool of servers or a list of servers that you're going to have load balanced. So this could be anything from a DNS name, it could be an IP, it could be a port, it could even be a localhost Unix socket. Whatever the case, these server entries exist in the upstream config. Then we have our server config, or a server block, which is basically what we're using to proxy to the upstream. So in other words, this is listening on the default port interface. You'll have a root directory where you're serving all your error pages from and whatnot. And then the proxy pass, as you can see, is proxying to the upstream itself. Now, a lot of you said you're looking for load balancing across HTTPS. If you are going to re-encrypt the traffic to your upstream, you're going to have to use, we don't cover it today, but you are going to have to use a couple directives such as proxy SSL certificate. You're going to have to use proxy SSL certificate key. And if you're using a self-signed cert, I do recommend using proxy, I think it's verify off or something like that, and verify depth to verify that it's actually an encrypted key. And then, yeah, go ahead.
I apologize. I raised my hand, so I wasn't sure if it's. So when you're dealing with the DNS entries, and what I've done a state directive, so all my upstreams are in the states. But what I've noticed, every time I use the DNS, it actually, every time I restart the service, it reverts back to the DNS, even though I may update the state. Is that accurate for the new version?
So you're saying you're using a state directive, and then it's basically going to rely on what's in the DNS cache. Whatever. So is it a local DNS server, or is it like external?
No, it's a local DNS server. But when I like upstream in my state directive, it says server xyz dot chris.com, right?
Right.
And even though I made the change in the configuration screen, we can actually go ahead and make dynamic changes.
Yeah.
Every time I restart the server, if I don't use an IP-specific server name, it reverts back to my DNS entries.
Interesting. I'll have to investigate that during the break. I'll ask the engineering team what kind of directives you can put to remedy that. I'm just going to ask: are you using the resolve director on each of your server entries?
I am not.
Okay, that might be one of the issues. Because I know when you restart and you're not using resolve, like on these individual server entries, it is going to query the DNS cache and upload those entries, right? So maybe with the resolve parameter on each of the server entries would fix that problem. It would also overwrite what's in the DNS cache, from what I understand too. But I'll check it. I'll check at the first break. Just remind me when we get to the first break, and I'll ask the engineering team.
Great. Thank you.
Okay. Some other people had their hands up. Did anyone else have any questions regarding that? Giancarlo, did you have a question? Giancarlo, did you have a question?
No, I don't have a question. Thanks.
Okay. Okay, so moving along. So for the selection algorithms, by default, when you deploy NGINX, you're going to get a weighted round robin. So basically that means it's just going to go down the line through the servers in your group. If you use IP hash or hash, that's pretty much Portman session persistence, where it uses a hashing key in the case of hash to determine what you're going to route or how you're going to route the request to your server. And then IP hash is basically going to take all the servers in your upstream. It's going to divide them by the IP ranges and then distribute the traffic evenly. Least connections is exactly what it sounds like. It's basically going to. Oh, you said your hand gets raised automatically. So Giancarlo, I think what was happening is I was trying to lower it at the exact same time you were raising it. So it wasn't the system. It was us. So with least connections, that's pretty much it's going to load balance to the server that has the least amount of active connections. Now this is kind of tricky because by default all of these servers have an equal amount of weight. So this is basically, if you don't want to worry about weighting, then you would use this directive. Now, whereas if you're worrying about the servers that are responding the fastest, you would use least time. Now, least time uses it basically takes all of the servers in your upstream. And it basically divides them or does some kind of algorithm where it takes either the first byte of the response header or the last byte of the response header, and it averages that across all your servers. It takes a mean average of whatever that latency is, and it will basically select the server that's responding the fastest based on that average mean. So this is more recommended for like advanced setups, and it is an NGINX Plus only algorithm. Okay, so let us create our first exercise here. This will kind of be our base config that we're going to use throughout the rest of today. So I want you to change directory into conf.d and back up. There may or may not be a configuration in there called webserver.conf. If there isn't, don't worry about it. But if there is some other config in there, go ahead and back it up or remove it. And I want you to create a new file called main.conf. Now this configuration is going to listen on port 80, and I want you to add the 3 Tomcat servers in your upstream block. Now those should be on your sheet. If they are not, I will I'll do this lab with you, and I'll leave my config up so you guys can copy it. I can also post it in the chat window as well. The most important thing to remember here, though, is to make sure each of those servers are listening on port 8080 in your upstream. So once you're done with your upstream config, then you're going to open your server, which is going to be listening on 80, and then you're going to create a location prefix that's going to proxy to your upstream group. Once you have that, go ahead and create an error log with a level of info, and then an access log with a level of HTTP compliant. Can you guys hear me?
We lost you for a minute.
Okay, what did you miss?
Pretty much all that you said.
Okay. I was basically just explaining the lab instructions here. So you may or may not have this configuration in your instances, so feel free to remove it if you find it. And for that matter, anything that's in conf.d, just remove it. Replace it with main.conf, and this is going to be a server that listens on port 80. You're going to add the 3 Tomcat servers that I mentioned earlier in your upstream. I have those servers on hand if you don't find them in your email or whatnot. But the most important thing is to remember that they're listening on 8080. Then I want you to create a location prefix that's basically proxying to your upstream, and then also create an error log and an access log. So I'll do this with you, and then I'll leave my configuration up so people can catch up. Okay. So the first thing to do is make sure that we don't have anything inside conf.d, which we do. We have a default config. So I'm just going to remove it because we're going to create a new one from scratch. So once you're in conf.d, you can use any text editor you want. I'm going to use Vim. And I do have to use sudo when you're in this directory. So you can either elevate your privileges to root if you want, or you can add your student whatever number to the NGINX group, and you should be able to edit in this directory without using sudo. Whatever the case, make sure you create it with root level privileges. So now we have this main.conf, and I'm going to create an upstream. I'm going to call it my servers. And for the servers, oh, there's a tab issue there. That's going to bug me. Let me go back to my home directory. This isn't that big of a deal. It's just something that irks me. Everything has to look nice. Okay. So back in conf.d, I'm going to open up main.conf. See if it worked. Yep. Okay, so I'm going to put 3 servers in here, and let me go ahead and pull them up. So first one is backend 1. This will be our first Tomcat server. And I will actually put this in the chat window for everyone, just to make it easier, in case you guys can't find it. So that's the first one. And we're going to do backend 2. And we are sharing backends, so be gentle and don't do any port scanning or hit it with a bunch of load. And this is backend 3. Okay, so that's our upstream config. Let me put the second one in the chat window. And this will be the third one. Okay, so that's our upstream. The next thing we need to do is create a server. This is going to listen on the default port interface. I'm going to set the root directory to just the default NGINX root directory. And then I'm going to create a location that's going to match against all prefixes, basically all URIs. And it is going to proxy pass to HTTP my servers. Lastly, I want to create an error log and an access log. Can you guys still hear me?
Yes.
Okay.
Yep.
And we can call this main.access.log. And then we'll do error log var nginx log main.error.log. And actually that should be info and this one should be combined. Okay, so that's all we should have for now. I'll give you guys a minute to catch up. Let me know when you're ready to go. If you are done, you can go ahead and save this, reload NGINX. First, you should do NGINX-T, and then it will tell you if there's anything wrong. Looks like there is something wrong with mine. I forgot a semicolon. Access log var. I see what I did wrong. Got a little too excited. So it's actually var log NGINX, not NGINX log. Fat fingers.
Hey, quick question. Why do we have a root directive when the HTML should be on those servers?
This is for your error pages. So in case something can't reach the upstream, it's going to serve an error page directly from NGINX. So this isn't.
Oh, that's cool.
Yeah, this isn't necessarily the root directives on here. It's just the root
Yeah,
directive.
exactly.
Right.
Okay, cool. Thanks.
Okay, cool.
Yeah, it makes perfect sense.
And one thing that's a good point. So one thing we don't actually cover in the course today is there is an error page directive too. And then the point of the root directive at that point would be totally null and void, because basically you could take each error code and then have it go to a specific, a file in that case. Well, I guess you would still need the root directive, but you get what I'm saying. So I could have error page, I could list all the 500 codes here, for example, like 500, 502, 503, and then that would be, I think it's called 50x.html or something like that. Anyway, those are the default error pages, but I do recommend changing those and creating your own error pages because the ones NGINX have are kind of boring. Okay, looks like everything's good then. Then we would reload, and if you want to do a curl HTTP localhost, I should see something that says this is backend 1 in the header. I can also go to a web browser and test it, which will look a lot prettier. So let me go ahead and take my host name. And as you can see, it's already kicking in with round robin. Oh, it skipped the third one for some reason. There we go. So we have 1, 2, and 3. So let me go back to my config so you guys can see it. Okay, so I'll give you guys about 2 to 3 minutes to catch up on that, and let me know when you're ready to go on. It looks like one of you is already ready, so let's just give everyone else a few more minutes, and then we'll go ahead and move on. Okay, let's go ahead and move on. So that was our basic setup. The next thing I want to talk about, last thing I want to add. We will add this later if you forget now, but feel free to add a zone directive in your upstream. This will be really important when we do anything dynamic a little bit later today. So this will include if we want to use the API or if you want to you will have these machines for about the rest of today. So if you want to play around with it and you want to do anything dynamic and take advantage of some of the dynamic features, you will have to use a zone directive. And basically, what that does is it creates a shared memory zone where a lot of the upstream information can be shared across the worker processes. So don't worry if you haven't added it. We're going to add it later anyway. Okay, so the next thing I want to talk about is migrating from hardware load balancer. I know a lot of you said you're not really necessarily moving from a hardware load balancer, but this concept still applies whether you're moving from a different software load balancer or you're introducing NGINX into the stack to do your load balancing. The great thing here is it can work in parallel with whatever you're using already. There are some terminology differences in terms if you're coming from a hardware background, and I'll go over those very shortly. But more importantly, the most important thing to remember is there are two big migration mistakes that almost everyone makes. And one is an excessive use of the rewrite directive if you're just trying to do redirects and redirect requests, use a return directive instead. And the reason why is because rewrites take up a lot of connection overhead if they're used too liberally. So be conservative with your rewrites, and also to piggyback on the rewrite directive, I also see a lot of incorrect uses of the if directive. Now, the if directive is a parameter of the actual rewrite directive, and the two biggest mistakes I see people using the if directive for is if they're trying to search for files that exist on disks, they're using the if directive instead of try files. And the other one is that they're using if to dynamically set variables, which they shouldn't be doing. If you're trying to do it at the HTTP level, you should be using a map instead. And these are just two big examples of configuration mistakes. So in your slide deck, this is an embedded link. I do recommend everyone read this. It talks about all the issues that when you're making your configs, or if you have something else that's orchestrating or templating your configs, you want to make sure that you avoid these pitfalls. Okay. So more about the if directive. Why is it so dangerous? The if directive is basically kind of like a nested condition or a nested location. In other words, if the condition that's in the if directive is true, the if directive basically, or whatever else is specified inside the if directive, is going to be executed. And that initial request that was assigned to the config will also execute anything further. It's worth mentioning here that any configurations inside the if directive are inherited from the previous config. So you can basically think of this as a nested location. So it's like a location within a location. And this is why the problems are such a big deal. Because let's say, for example, if you have a location inside a location, that means it's going to check against, and there's a match for the initial prefix. It's going to execute that if directive no matter what, every single time there's a match for that location, whether or not that condition is true or not. Which is why the only 100% safe use cases is a return and a rewrite, because this doesn't take too much overhead, and this one is a little bit more minimal. Whereas dynamically assigning variables and adding headers and things like that can cause your server to segfault, in other words, crash. So be aware of the if directive. If you do need to if you, for whatever reason, you have to have it do some kind of dynamic variable assignment or whatever, make sure you do that at the server level. In other words, not inside a location block, and it will be a little bit safer. And I mentioned the try files directive a little bit earlier, just to explain what it does. Is it's basically taking place of the if directive to search for files, because in old iterations of NGINX and old versions, people were using the if directive and they were, doing some regex in the if condition to look for a variable or an argument, and then they were performing some logic based on that output. So NGINX decided to make a directive to do that for you called try files. And basically what it does is it takes the variable name, which in this case is a URI, tries to match it against a prefix. If it can't find it, you can do two things. You can force it to an error code, or you can force it to an internal named location. So in this case, it would be proxy. And here it would look like this. So here you have at location proxy. This is an internal location that can only be accessed via NGINX, not by the client. And maybe it's going to fall back to a default location or something like that. So that's the try files directive in a nutshell. Okay, so I'm going to go through this quickly because it doesn't sound like this is relevant to any of you. But let's say, for example, you're migrating from a hardware load balancer, the Citrix F5 Big IP, to NGINX Plus. There are some terminology differences here, and the most important ones I want to go over are the virtual server. So in NGINX, your virtual server is essentially your server and location block. It's also your server name directive as well. And your pool and node list is going to be your upstream, as well as any iRules, which, if you're not familiar with Citrix, iRules are kind of like, imagine server-side scripts that you're basically creating to do some advanced traffic routing. You can do that in NGINX using multiple methods. You can use server location logic, with modifiers and whatnot. You can attach the NGINX Lua module, which a lot of customers like to do. It is an open source third-party module, so it doesn't offer, NGINX won't offer support if there's problems with it, but there is a really big community around it that will be willing to help you out. Or the one that NGINX will provide support on is NGINScript. And NGINScript it's JavaScript implementation of server-side scripting, or server-side includes. And then for high availability, we will cover this later, but we do have a Keep Alive D implementation. So for those of you who this is relevant to you and you are migrating from an F5, there are some configuration examples here that I'm not going to go over because it didn't sound like it was relevant to any of you. But feel free to look through that if you ever in the future have to do this. And there's also a link here to a migration guide as well. It'll basically give you a list of the hardware appliances and then give you configuration equivalents, which is pretty nice. Same thing for NetScaler. These are the various terminology differences and what they mean in NGINX. The most important thing here that you will encounter no matter what you're using is a VIP. And I want to say that in NGINX, it's pretty much the same concept. Although if you're going to use NGINX in a high availability implementation, you need to have something other than NGINX to manage that VIP. The reason why is because NGINX isn't really aware of its own implementation. You need another process ID or another daemon process to run in parallel with NGINX to basically monitor the NGINX implementation itself, because you don't want NGINX to be a single point of failure. And if the implementation or that instance goes down, or let's say the service is down for whatever reason, you want something to be able to transfer the VIP to another NGINX instance quickly. But it can take a VIP if you do have an NGINX instance acting as your, whatever the tool to define mastership and whatnot. And the same concepts are pretty much the same here. So server, service group, service pool, it's going to be the same as an upstream, and then high availability is that implementation I was talking about earlier. Okay, so deployment scenarios, let's just go over these really quickly. Let's say a client wants to connect directly to NGINX Plus, and NGINX Plus is basically going to be your primary touch point for clients, and it's basically going to be doing all your load balancing. And you may notice that this looks like it's opening a equivalent TCP connection to the backend. If you were to use HTTP 2, this would be a single thread probably, or a single connection to each backend, rather than replicating an exact TCP connection. So that's just one thing I wanted to mention. So this is if you have NGINX, it's doing all your load balancing, all your routing, all your reverse proxying. Another scenario is you have NGINX running in parallel with something else. Like in this case, it's a hardware load balancer. This scenario is usually applied where you have a data center and both the hardware load balancer and NGINX Plus live. Sometimes you'll have the hardware load balancers are migrating legacy data, while NGINX Plus is basically deployed in a hybrid cloud or in a parallel data center. And the usual reason for deploying this is you want the company to move to a more modern software-based application, but you don't want to rip and replace any legacy hardware that's doing something that's business crucial. And then the third scenario, I see this one a lot, and this is pretty much you're wanting to migrate to NGINX slowly. So what you do is you drop NGINX behind whatever it is you're using to route your traffic, and then you slowly turn off any of the hardware capabilities and then offload it to NGINX. The downside with this approach is you'll have, let's just put it this way. It's kind of a waterfall format with, deployment strategies. So there might be a lot of bottlenecks in terms of, change requests and features and enhancements. You may also run into problems where you'll have two teams working in silos. So in other words, you'll have like the network team that's managing the hardware load balancer, and then you'll have your dev team or your DevOps team that's managing NGINX. And then there might be contention between the two. Ideally, you'll have one team that manages both of these layers, and then it won't be a problem anymore. But this is a totally okay implementation of NGINX as long as you're aware of what needs to stay here and what needs to pass through NGINX as well. Oh, and we do actually talk about error page directive today. So this is just a rehash of what I was talking about earlier. Rather than rely on the root directive, you can use an error page directive to basically point to specific pages depending on the response you get from the backend or an error that you want to serve to the client. So these are the old status monitoring. These are the old status monitoring directives, and I don't think this slide deck's been updated. But we used to have this module called status, and this was for NGINX Plus only. We still have the stub status module, which is an open source monitoring directive. It is very limited, though. It only shows, I think, the amount of connections receives, byte receives, and active connections. If you want the newer NGINX Plus directive, you need to basically set this on. So you do API. If you want it to be so that's if it's read only. If you want it to be write, you have to do, I think it's write equals on, API write equals on. I think this is what it is. And that's the new API directive. Okay, so let's actually configure that right now. And I'm going to update these slides pretty quickly. Let's do API write equals on. There's also another location you're going to need. So you're going to need location. I actually don't think it needs to be an equal modifier. But down here, you definitely need one. Okay. So let's go ahead and create a new server. We won't need this root directive because that'll be really redundant. And actually, you know what? I'm just going to put the whole thing up here, and then I'm going to put it in the chat window for you guys. And apologies about the formatting. Yes, on host 1. Okay, so that's the config you're going to need. You can actually put this in the same config if you want. I recommend putting it in a separate file just so you can troubleshoot it a little bit easier. So for instance, I have a main.conf. We should create something called, dashboard.conf. And you may notice that this is not going to work immediately. And the reason why is because we need to actually add the shared memory zone that I was talking about earlier. It looks like my tab stop isn't working right now, so I'm going to quit this and just create it from scratch. Okay. Location. This is going to be API. And I'm actually going to make it read-only for now. I'll fix it a little bit later. Okay, and this is going to be equals/dashboard.html. And the reason it needs to be exact is so that the JSON, that the JavaScript can actually parse the JSON. User share NGINX HTML. Okay. And now when I go to my dashboard, I can basically take this, actually let me duplicate this. And then we do, what was that? I said 9090, right? 9090 dashboard.html. And there we go. So I don't have anything in the moment, and that's because of the fact that I didn't put that shared memory zone in there. So in order to get some metrics here, so basically this is showing basic metrics. I think this is pretty much the equivalent of what the stub status module would be showing you. So I go back into main.conf, and you add this zone. I can call this whatever I want, maybe HTTP backend. That sounds good. And I got to give it a size too, so let's do 64K. So I'm basically segmenting 64 kilobytes of the RAM, and then I reload, and boom, there's my upstream. You can also check the shared zone tab up here, and it will show you how many shared memory zones you have, how many, because of the size you segmented, it'll say this is the total amount of memory pages that you have, and then it will list everything. So this will list everything from your upstream shared memory zones, your cache shared memory zone, your limit rates, your SSL session caches, and everything. You can also link it to Amplify, which is our cloud monitoring tool. This is a pretty cool software. It will basically give you the capability of setting up alerts and things like that. And you can set up really complex rules and things like that to send you alerts via email or text message. And it's a free software. It's cloud-based only, though. So feel free to check that out in your test environments.
I've actually deployed that on a couple of my NGINX boxes, and it looks pretty cool.
Oh, cool. Did you create any like interesting rules or anything like that, like to set up alerts?
Yeah, I'm still having the challenge I have is the upstream directives. And
I see.
On the upstreams.
Okay. Ooh,
but it's a pretty cool product.
Giancarlo, you asked a question. Okay, what was the directive for the backend cache thing? Oh, it was actually for the shared memory zone, but I'll show you in a moment. We will talk about caching later, though. That's a good point. So I think you're referring to this, right, Giancarlo?
Yeah, that was exactly what I was referring to. Thank you.
Okay, cool. And by the way, this name is totally arbitrary. I just named the shared memory zone something that I can identify as, oh, okay, this is probably used for the HTT upstream, you know? All right, so I think we're going to get into something pretty hairy in a minute. We're going to get into session affinity. So this is probably a good time to take our first 10-minute break. So it's about 10 o'clock right now. Let's come back at about 10 after 10. Does that sound good to everyone? That way you can go to use the restroom, get coffee, do whatever you need to do.
In the meantime, can you please show us the backend or the dashboard conf?
Yeah, sure.
Please.
I'll actually open up a new tab or a new window,
Thanks.
and I'll show them side by side. You know, every time I teach this class, I should save my views so that I can just have like 4 of these up at once, but I always forget. Maybe I'll remember today. Okay, let me pull up my host name again. All right.
Yeah.
Okay, so hopefully you all have your dashboard running as well as your load balancer. Excuse me. The next thing I want to talk about is session affinity. Now, if you notice in the upper left-hand corner, I have an NGINX Plus symbol. This is pretty much anytime that you see this in the presentation today, it's relegating whatever topic I'm talking about to the enterprise version of NGINX. Now, having said that, you still can achieve session affinity, at least to some extent, using hash and IP hash. But these 3 directives here are a fair bit more robust, and that's why they're part of the enterprise-only feature. Now, the reason for using this is whether you're using cloud-based solutions or on-prem high availability, it's always a good idea to enable sticky sessions so that the clients don't have to rely on your server-side states. Or another use case for using these are, let's say you have certain applications on your backend that need to store session and state data on the upstream server. And these three directives will make sure that the client request routes to the same IP after subsequent requests in order to maintain that application functionality. So the three we have here are sticky cookie, sticky route, and sticky learn. So with sticky cookie pretty much uses an HTTP cookie to identify the upstream server. That cookie is inserted by NGINX for the first response from the upstream server. Then any subsequent requests from the same client will be passed to that same server based on the cookie data. If for whatever reason the server can't be identified, another server will be chosen based on whatever routing method you have. In this case, it would be round robin. So let's say, for example, a client makes a connection to the server. It will go to the backend because there's no cookie data currently. The response will be received by NGINX, and then it will insert the cookie data. So it will have cookie. You'll have the cookie, the name of the cookie, how long the cookie lasts for. In this case, it'll be an hour. The domain that it's set for, if there's a match. So if the response is from example.com, it will set the cookie. And then as well as the path. So in other words, the cookie will only be inserted if the path or the URI path matches in the response. So let's say, for example, you have a shopping cart application that will be something like /cart. And this is another use case for having sticky sessions too. So, if you have data that you need to keep in a shopping cart so that, a customer can peruse your site at will, but still want to keep their data that they've placed in the cart, even when they continue to check out. This is one example of keeping that data, or keeping that session rather, persistent. Sticky route is another way that you can route traffic. The advantage here is that the routing is way more robust than the other three algorithms or directives. The downside is it does require a lot of configuration on the back end. So for example, let's say a client is assigned a route from the backend proxy server the first time it sends a request. That routing information will then be stored either in a cookie or a response URI. That way, subsequent requests will be able to determine where it went based on whatever the backend inserted. So the difference between this one and the previous one is that the backend is what's inserting the information, and NGINX is just capturing it using sticky route. So this perfect example would be if you have a Tomcat server, which we do, and the Tomcat server has some kind of application or servlet that's basically inserting a JSession ID for Java. NGINX can capture that JSession ID, which will then route based on the JSession ID to the backend. Now you may be wondering, okay, that sounds great, but how is this directive here doing that? Well, the answer is we need to find a way to capture that session ID and store it in a variable. And then these two variables, which are custom variables, by the way, NGINX sticky route, or sticky route itself, is going to take the first non-empty value. So it's going to first check for a route cookie variable in the response, and if it can't find anything, and it'll also check the request too, it will move on to the next one, which in this case would be route URI. So this is what it looks like. On the backend servers, I would need to go into the server.xml file, and this is what I meant when I said I need to configure the backend. So I would go into the server.xml file, which is like kind of the server configuration for Tomcat, and I would need to enable this parameter, which is called JVM route. And I would name it with some value. In this case, it's Tomcat 1, 2, and 3. But if we go back to the previous slide, this would be backend 1, backend 2, and backend 3. And what that's going to do is whenever a client makes a connection to one of these three servers, it's going to append this value to the session ID and then insert it in the response. That way it's able to route traffic. Now, that's how it generally works, but how does NGINX actually capture that value? Okay, someone had a question. Let me take a look. Alex, you had a question?
Yeah, I actually had a statement. I try to use that with a JSON, the route, and I found out that it varies from browser to browser how the response are.
Okay.
So I was able to get it working fine in Chrome, but when I try to use IE, it didn't work.
Okay,
Just
so
FYI.
oh, okay, so I mean that kind of makes sense. I don't know how Internet Explorer handles the JSON payload, but my guess is um, something got lost in translation in the response.
Yep. So the only way I was able to get it working is through learning directive.
Through the sticky learn directive.
Sticky learn directive. Yep.
Yeah, and that was going to be the next one I talk about, so I'm glad you brought that up. Sticky Learn's probably the most powerful of the three. It just has a limitation of if you were to have multiple instances of NGINX, it wouldn't be able to share that routing table, which kind of sucks. But yeah, route is robust, but again, like Alex mentioned, there are some variables to be aware of, like browser capabilities and which agent that the client is using. But in any case, you would need to use a map on NGINX to capture that value as it's coming back and going forward. So what these two variables or maps are doing, and if you guys aren't familiar with maps, a map is pretty much, think of it like a hash map. I think that's why they actually called it map. But it's a way to basically set variables dynamically in the HTTP context. So basically what this map is doing is we have cookie JSession ID, and this is basically the value of this variable, the second one here, is always dependent on the first one. So this first variable is the variable that's coming back from Tomcat, and this is going to be the cookie JSession ID. So if you're familiar with JSession IDs, it's basically taking a really long string. And because I've enabled the JVM route parameter, I'm going to use that in my capture group to say find some kind of character before and after route, to basically in whatever number that may be, and then set it to the route variable. And then I'm doing the same thing with the request URI. So this is if it fails to capture it on the response, you can try and capture it on the subsequent request in the request URI itself. And we're doing the same thing. We're checking the JSession ID, checking the route variable, setting it to the route, and then route URI is going to equal whatever the route is. Okay, sticky learn. This is when the upstream server creates a session. Like Alex was saying, it could be an HTTP cookie, it could be a JSON payload, it could be a URL token, it could be pretty much anything. And NGINX will have to learn which cookie or JSON payload or URL token corresponds with which upstream server. This way, when a client request contains a session cookie or whatever the payload is, NGINX will forward the request to that appropriate server. And the way it works here is you have sticky learn, you're creating the upstream value. So it could be a cookie, JSession ID, or whatever. You're creating a lookup value, which is basically the table that it's going to map to internally. And then a zone where it's actually storing that information. So this is, again, another shared memory zone that you would see if you went to your dashboard. It would show the size of the zone and how much is being used within that zone. And then, of course, you set it for your backend here. So the benefit here is you don't need too much configuration. The downside is you won't be able to share this information if you have multiple instances of NGINX. Unless, of course, you maybe map it to some external source and then pull it that way. But that would require some scripting, server-side scripting to get that done, I believe.
When you say multiple instances, you're talking about active instances, correct?
Yeah, that's what I'm talking about. So I've only seen that method work with a single instance of NGINX. Unless, I don't know, have you gotten it to work any other way?
I have an active passive node, so it works fine.
Oh, okay. So, you know what's happening there? You may have some kind of syncing mechanism to replicate your configs and whatnot, and maybe that's how it's working.
That's correct.
Yeah, so you're pushing the shared memory zone as a silent partner or whatnot. Okay, so in that case, yeah, I guess active-passive it would work. Active-active, I'm not quite sure. I don't think it would work. But active-passive, I could see it working. Okay, so with sticky learn, here we have a session ID cookie. In this example, I'm using a cookie. So it's pushing to server.backend1. The cookie is not found, so the request is load balanced based on whatever the selection algorithm is. So this would be, I guess, round robin in this case. Upstream server serves the response, and here's the cookie data. So session ID equals blah, blah, blah. NGINX is going to store that in memory, and it's going to map that value in the shared memory zone. So it's going to store that information in the shared memory zone for however long it can exist in the memory zone, or if you like with a timeout parameter, or if it hits its upper limits, it will take the least access key and then evict it from the shared memory zone. So then, which doesn't happen that often because this is really small data. Then it will serve the response and append it to the response URI back to the client. Next request that comes through, NGINX will check that mapping table in the shared memory zone, and then it will load balance to that previous server. Okay, so we're going to do Tomcat route, and if you haven't already, I want you guys to create this custom log format just so we can get some more interesting log information when we check the logs. So open up main.conf, and in the HTTP context, which would be above your upstream or below your upstream, I want you to create a log format called sticky, and it's going to log the following. And by the way, this is all on separate lines just so you can read it better, but I recommend putting this on one line. So we have request equals request, status equals status, and these are all variables, by the way. Client's going to be the remote address, so this is going to be the IP of who's making the request. Then you're going to have the upstream address, which in this case would be the IP address of the Tomcat servers, and then those custom variables that I mentioned earlier. Then, when you have that log format created, we're going to replace the access log with that custom log type. So let's go ahead and do this together. So first things first, I am going to create this log format down here. So we'll do request -n, and actually I'm just going to do it like this. So we'll do status $status, and then we'll do upstream IP, and I will place this in the chat window for everyone if everyone's feeling lazy today on this Monday. Because ideally, I guess when you're doing your configs and you're trying to do research on what you'd want to put in there, I do imagine a lot of it's going to be copy and paste and test. Or you're going to be using something to template your configs, which is a modern way to do it. Okay. So that is the entire log format that we're going to be using. Pasting it in the chat window for everyone. Whoa, what happened to route cookie? Okay, so route cookie looks like it decided to create its own indentation in the chat window, so ignore that. Yeah, that's probably because of my window size. Okay. Next thing you're going to do is replace the combined format with sticky.
Hey, what about the client directive on the log format?
Oh yeah, I think I forgot that one. Thanks. I don't remember where I put it. Was it after client or after status? Got it. Okay. So that is the full address, or sorry, the full log format. The next thing you want to do is replace it with sticky, and the next slide, or I'm going to do all these changes all at once. So then we're going to add a route to each of the upstreams, so I'll do that first. So up here at the top, this will be route equals, and I did this in order, so make sure you copy the backends in order. This is going to be route equals backend 1. This is going to be route equals backend 2. Route equals backend 3. And then the next thing, we're going to add the sticky route parameter. That's going to be at the bottom of the upstream. So we'll do sticky route, and this will be route cookie route URI. And then finally, we have these maps here, which I'm just going to copy and paste. So these need to also be in the HTTP context. I'm just going to do them right below the upstream here. Okay, so that's pretty much all we need. I'm going to leave this up for a couple minutes and let people copy. I'm also going to copy this to the chat window because sometimes people mess up with the regex. So let me go ahead and post those in the chat window for you. And once you're done with that, go ahead and reload. And actually, I'll wait till everyone's done and then we'll all test together. So let me know when you're finished. Alex, you had another question? All right. Okay, so first and
I'm having a problem with the log file actually.
Oh, really? What happened?
Give me 1 second. Yeah, I don't know. It doesn't like my configuration.
Okay.
1 more minute.
1 more minute? Okay.
Yeah.
For those of you who want to test and go ahead, let me show you how to do that. So to test, there's 3 things I would do. You can test multiple times using curl, and to see if it sticks. You'll probably notice it won't stick right away. And it actually wouldn't be localhost 8080, it would just be localhost. What you can do is you can run a tail command, and then check your upstream access log. And then when you're hitting the site, what you're going to want to do is go to examples, servlet, session example. I'll show you here. So go to examples, go to servlet examples, and right here there should be a session application. If you want to check the source code, you can see that it's inserting a session data. Where is it? New session, yeah. So this entire part right here is creating a session ID. So it's creating an HTTP session, and then it will insert the J session ID. So when I do this, you can see that it inserted something, and it also appended that JVM route parameter. And then when I hit refresh, if you did it right, when you hit refresh, you should see that it sticks. And then, you know, if you want to make sure it actually is sticking, like you go back and hit refresh a few times. And if I do sudo tail -f var log NGINX upstream access log, and that's not actually a log file. I think I did main.access.log. Here you can see that it is sticking. So it's sticking to the route cookie. The upstream address will stay the same. And yes, this is my client IP. Don't hack me. So if I hit refresh again, you can see, boom, it stuck to the same IP address. No matter where I'm at in the entire site, it's going to stick. Now, the one exception is the landing page. You can see that it strips away the cookie and that it's basically load balancing that way. And you can also see, because when I hit refresh, it's round robining, as they would say. But if I go back to the session, hit refresh here, you can see that it sticks again. So did you guys catch that? I'll put the tail command in the chat window if you guys missed it. Okay, Alex, did you need me to look at your config, see what's going on?
No, I'm good.
You're good now? Good.
Yep.
Okay, cool. So let's move on to the next section. Does anyone need more time to test that? 1 or 2 minutes? No? Yes?
Just a quick question. So you're currently localhost or on
yeah.
port 8080?
Yeah, so on the local, when I was in the instance, I'm going to go like this. And this is going to revert to round robin. But if I go to examples / servlets / servlet, this is going to give me an error. So don't do that in curl. I would actually just do it through the browser. So take your browser, go to sessions, and then hit execute. So if I were to take this URI, there we go, curl HTTP localhost. Let's see what this returns. Yeah, so this is just going to print out the HTML. And I would have to insert the / I think it's X parameter to actually execute the command. So I would just use the dashboard because I don't remember what the actual curl example would be. Okay, so that's how you do this. And then check your log to make sure that it is exactly sticking. But the first indication that it's not working is if you hit refresh here and you see this parameter changing, as well as the entire ID.
You can also see it in your dashboard. It increases your the same upstream server increases total count.
Right. Yeah. So if you see, like what Alex said, if I see a drastic differentiation between the traffic here, which I do, that's indicating that it's working. You can also check your shared memory zone too, I believe. Actually, that's not gonna, actually because I'm using route, it's not going to store it in memory, so never mind. Okay, let's move on to the next section. So the next section is TCP UDP load balancing. This, up till now, we've been using layer 7 load balancing. Now we're going to explore a little bit of the differences between layer 4 and layer 7. And the big thing here is to differentiate between stream and the HTTP context. We're also going to configure logging for TCP UDP upstream, as well as active health checks for the stream context. So from a high level, what's the primary difference between HTTP and stream? Well, the big differences are at the layer 7, which is HTTP. This pretty much operates at the highest application layer, which deals with the actual content of each request or each message. It is the predominant protocol for layer 7, or sorry, HTTP is the predominant protocol for layer 7 and for website traffic in general. Layer 7 load balancers usually route network traffic in a much more sophisticated way than layer 4 load balancers. And this is particularly true of TCP-based traffic such as HTTP or HTTPS. A layer 7 load balancer will always, or most always, terminate the network traffic and then read the message within. When it does that, it can make load balancing decisions based on content of the message. So like the URL cookie, for example. It then will make or establish a new TCP connection to whatever your upstream server is, whether it's application or a web server. And then you also have the capability of reusing it by setting, HTTP keep alives. Now, layer 4 operates at the intermediate transport layer, and this deals with the delivery of messages with actual no regard for the content of the message. This is called the Transmission Control Protocol, TCP, and it uses it's the layer 4 protocol for all hypertext transfer protocols, HTTP traffic. It also uses UDP traffic too, which is like datagrams and such. What it typically does is it just simply forwards the network packets from the upstream server without inspecting the content of those packets. Now the upside here is it's a little bit quicker. You can make, it has lower overhead, but it does have a little bit less network visibility in terms of the fact that you can't inspect the packets, or at least the full packet, to make any routing decisions. Now there are some exceptions in terms of like, SSL pass-through and whatnot, and we'll get to those in a minute. Okay, so just to recap, key differences, proxy pass, at least from an NGINX context, proxy pass directive is going to be relegated to the server context, and the main reason here is because with stream, you don't have headers anymore. You can't really inspect headers, you can't inject headers, so there's no point in having a location context. And in fact, if you try to put a location context in the stream context, it's going to yell at you and say, location directive is not allowed here. And the other difference with NGINX is that the active health checks are going to work a little bit differently than they do with layer 7 active health checks. Also, if you need to have IP transparency, meaning before when you wanted to retain client information that was passing through a proxy, you would use the proxy set header directive here. And this is with your layer 7. With layer 4, you can't necessarily do that, again, because there's no headers anymore. So you have to do something different. You'll have to use either our competitions protocol, this is the HA proxy protocol, or you would need to set up IP transparency, which we'll talk about in the next 2 slides. So with SSL server name routing, this is probably the easiest way to route traffic to make sure it's going where its target destination is. And basically what this does is it inspects the SSL certificates, or the SSL certificates, and it will inspect the SNI field to make sure that it passes the SSL or HTTPS request to the appropriate backend. And it's pretty easy to set up. You set up basically a map, and then based on the map, you do proxy pass, SSL pre-read server name, and then you make sure that the SSL pre-read directive is actually on in that server context. Now, this is a very simple implementation of this. It's just going to rely whatever's on the SNI field. So if you try this and it doesn't work, it could be that you're not even passing the SNI field. So that's something to be aware of when you're trying this routing method. Logging for stream, pretty simple. And funny story, we actually didn't used to have logging for the stream context a long time ago, and people, specifically customers, were like, dude, why don't you have logging for all your TCP traffic? So this, as of R11, we have implemented this feature, and you can log each TCP UDP session processed by the stream module, and you can do things like inspect data rates, you can inspect the load balancing decisions that were made, the error conditions, and so on. So the stream module does expose a large number of variables, and all of them can be logged, and you can also customize the default log format too. So here's just an example of some of the following variables that it's able to log, like the client IP, the timestamp, the protocol that was used, the bytes sent and received, the upstream sessions, upstream session time, the upstream address. If you're using HA proxy, you can use the proxy protocol address, etc. So a quick thing to be aware of with the TCP UDP considerations, you want to set your access control limits. So for TCP connections, because you're not able to make any complex routing decisions necessarily, it's a good idea to allow and deny this from specific IP ranges if you're going to make changes. You can also set the proxy download rate and upload rate to something reasonable, for all your post requests and whatnot. And it's also a good idea to set your limit rates. So you basically define a limit rate in your shared memory zone, and then invoke it in whatever server that you want to in your stream context. Another good thing, especially if you're load balancing MySQL traffic or any kind of database traffic, is to use the slow start. So let's say you have some backends, some database backends, whether it's RDS or whatever SQL database or Postgres or whatever, and you add a new one to your upstream or to the cluster. It's a good idea to use slow start when you add it as a parameter to the upstream so that you don't overload the database and get a bunch of bad entries in your tables and whatnot. You also want to make sure that you use maintenance parameters to handle failover, which we will cover a little bit later. So this is things for like database migrations, updates to the database. Maybe you're just doing some general maintenance or whatnot. You can use the drain parameter to basically say, for this upstream server, I don't want to take any new connections. And it's going to basically gracefully shut down the connections that are already in the queue before it transitions to the down parameter. So the down parameter means no active connections and no new connections. And then backup, as Alex was mentioning earlier, backup is what you would set any server, whether it's layer 7 or layer 4. And this is going to act as kind of a passive node in your upstream, so that if something happens to the primary node, or any other node rather, this will kick in and insert itself into the rotation and start taking connections. Okay, so enough talking. Let's go ahead and get back into the exercises. Let's go ahead and set up a stream context. What I recommend doing for stream is rather than create a bunch of configurations with a stream context, what you should do is go into the global config and do the same cadence that the HTTP directive follows. You have a stream context, and then you use an include to basically include all TCP or UDP comp files. So go ahead in your nginx.conf file, and I'll do it with you. So I'm basically going to, let me clear my screen really quick. I'm going to go up one directory, and I'm going to create that new directory, which will be, or actually, let me see if it's already there. No, it's not. So I'm going to create a directory called TCP, and then I'm going to open up nginx.conf, and right above the HTTP context, I'm just going to create a stream context. So the stream context exists in the main context, which is the context where all these contexts really exist. And I'm going to use an include directive to point to that directory I just created. And what I'm going to do is say process any comp files in that directive within the stream context. So the benefit here is I can have multiple TCP, UDP configurations, and it's going to inherit the stream context here. So if you did want to do any performance tuning directives in the stream context, you would place them here, and it would apply to all the configs, or you can place them in any of the other configs as long as they're above the server, and they will also be able to be accessed from the other configs. So now I go to TCP, and let's create that file. So it says to create tcp_lb.conf. So now I'm in tcp/lb.conf. Then we're going to create the TCP upstream. So we're basically going to copy our upstream from the previous config. The only change I want you to make is the name of the upstream and the name of the zone. But it's pretty much going to use the same stuff. So we can do this by going to, So actually, before I do this, I'm going to go back and copy that stuff to my clipboard. So I go to conf.d, go to main. I'm not going to copy the sticky. I'm just going to copy all this junk. Go up one directory to TCP. We'll go to upstream. I'll call this TCP backend. I'm going to create a zone called TCP upstream. You know what? Just to keep it consistent, I'm going to call this TCP upstream, and then I'll call my zone TCP backend. I'll keep it the same as the HTTP backend. And then I copy the server names. Now we don't need the route parameters anymore for this, so I'm just going to delete them. And that's it for the upstream. Then we do a server, and I'm going to have this one listen on 8080. And it's going to do proxy pass TCP backend. Now you may be wondering, okay, with the proxy pass directive, how come you don't have to do TCP or anything like that in front of it? Now, the default for stream context is always going to be TCP. If you need a different protocol, you will have to specify it on the listen port, or you'll have to map it to a variable called proto, which we won't talk about in detail today, but that's basically what you would do if you needed to use something else like UDP or something else. Okay, so that's it. That's all we need for the upstream. I'll bring it back in a minute. I just want to reload and make sure I didn't make any typos. Okay, I did have an error there. zone, TCP backend, 64K. What did I do wrong? Oh, I forgot to change it. So this is going to be TCP upstream now. There we go. Now when I reload this, you should see it in your dashboard. There we go. So then we have TCP, UDP upstreams. You can also check your shared zones here, TCP backend, HTTP backend. It'll have separate tabs for all your TCP upstreams. Okay. Alex, you had a question or a comment?
Yeah, is there a way to set up a dynamic ports as opposed to like right now you got a server set up to 8080? If I want to do some kind of a map that is going to change my upstream port numbers, is there anything we could do about that?
Oh, you mean in the listen directive itself?
Actually, upstream directive is more like it. If I'm listening on port 80, I don't know.
You could use a variable. I think you could use proxy port or something like that. I think that's a variable you could use, but you would need to have a way to dynamically set it for each request, if that makes sense. So like, let me see. So it would be something like, proxy port.
Right.
And then you would do something in either in a map or in a service.
Right, that's what I mean. So in the map. But then what? In my listen directive, can I listen for a proxy port, or do I have to listen for a specific port?
Oh, you mean here? Let me double check. I don't have a definitive answer, but I can double check on the next break and give you an answer.
Right. I'm also being lazy. Can you post this in the chat window?
Sure enough, man.
Thanks, man.
What do you want me to post? The entire config?
Yeah.
Okay.
I'm on the East Coast, so I'm 3 hours ahead of you. I'm getting lazy.
Hey, no worries. Sound like you're from New York or something. Am I wrong or right?
Brooklyn, yeah.
Brooklyn, okay.
No, you're dead on, man.
I don't know the vocal cadences between the boroughs, but I do know New York when I hear it.
Yeah.
Okay. Let me pull it up for everyone, and it is about time for our next break, but I'll let everyone finish the lab before we take it. When we come back from break, we're going to talk about active health checks with regards to. Oh man, Martin's in Europe. I think you beat Alex in terms of what time it is. Yes. So when we come back from break, we'll talk about active health checks with UDP and TCP. If you're done and you got everything working, you have it in the dashboard, feel free to take your break now. We'll come back at about 11:10. Give you a couple extra minutes. If you want to stick around and work on this, feel free. I'll be here for the next couple minutes to answer any questions. So it's about 10:57 right now. Let's come back at about 10 after. Does that sound good to everyone?
Yes, sir.
Okay. Okay, so Alex, are you still there?
Sure am.
So I just asked the engineering team, and I also just checked with the documentation, and it looks like the listen directive itself, so not the parameter on the upstream, but the listen directive itself doesn't support variables or env variables, so it can't listen on an NGINX port
Okay.
dynamically. It
So you
basically
would have to, go
what?
ahead, I'm sorry. No, I'm sorry. Go ahead.
Yeah, I was just going to say it can't be implemented because it has to be defined before it even starts receiving HTTP requests.
Mhm.
That having said, uh, if you do a hard restart of NGINX, you could potentially have some kind of script to modify the listen directive on restart. But that's not really a safe way to do it, as
Okay.
what I'm guessing.
But we could still do a proxy pass on the upstream, correct?
Yeah, you could do a proxy pass and then have a variable on that's doing like the port and information here, right? So
Yeah.
you could either define it as a variable on the upstream, or you could do it like proxy port or something like that.
Got it.
Yeah.
And then map it out, correct?
Yep.
Okay.
Yeah. So long story short, there are some hacky ways to get around it, but by default, this is pretty static.
Okay. Because I actually had to set something like that up, and I had like 40 directives that I needed to recreate, and it was more like, mind boring, cut and paste, and change port.
Right.
So I was hoping there was a dynamic way I could do it, but I guess I could still use it upstream. I can change it, but not the server. I would still need to create like 40 directives.
40 servers or with
Server directives, yeah.
yeah.
Okay, that's good to know, though.
Yeah, I think the only hack way I could think of doing it is if you're doing some like a more advanced deployment of NGINX, like a microservice deployment or something, you could set it in a template file or an app definition file, right? And then it would spin up X amount of NGINX containers with various port numbers and whatnot. So you could do it that way. But static configurations, I'm not sure. I don't think it's possible.
Okay, thanks.
Okay, so hopefully you have your TCP upstream working. The next thing I want to cover is how do we check to see if it's actually working. We haven't done that. We just assume it's working, but it's not actually. I mean, I guess you could do it the manual way. You could do it telnet, right? You could do telnet, localhost. What did I say? 8080? Yeah, okay. So that's one connection. But how do we check all three? Well, the one thing we could do is we could set up a for loop and do that, or we could do an active health check. So with an active health check, we could just set up the health check directive. Let's do a really dumb active health check. Would just be pretty much health check. And this is the equivalent of us just doing a telnet to each thing. So let's do reload. And we should see, yeah, health monitors. Now what this is doing is it's basically just pinging it to make sure that it's getting some kind of response. But how do we know if it's the correct response is the real question. Now, because we're communicating over HTTP, we should expect some kind of 200 response code. But again, because we can't inspect the status header or anything like that, we need to actually pass the string value and expect a string value back. And that's exactly what these two directives do for the TCP health check. So send is you're going to send a text string, or if it's UDP, you're going to be sending a hexadecimal. And basically you need to know what you're going to expect back in terms of regex data in order to check the health of the actual server itself. Now, in terms of active health checks, it has the same parameters as the layer 7, so you can still adjust the interval, you can still adjust the pass-fail ratio, and you also have the access to the match block, which is where we do our sophisticated health checks. So that's what we're going to do in our next lab. We're basically going to create the health check. Let's adjust the interval to something crazy, like 10 seconds. We'll set the passes to 3 and the failures to 1. And then we're going to set our match block to something called HTTP. So let's go ahead and do that now. So here I'm going to set it to interval equals 10 seconds. Passes is going to be 3. fails, I want it to take it out of rotation immediately if there's a problem. And then match is going to be called HTTP. Next, I have to create my match block, which is going to be called HTTP to match what this is. And I'm going to do send. Now we're using a GET request, so I'm going to do get the version of HTTP, which I believe is 1.0. Could be wrong. And then we're going to do host localhost 8080. Okay, so that's the string message that I'm sending. What I should expect back is some form of 200 OK. So I'm going to use a case insensitive regex, and it's going to be OK. Everything's going to be OK. Go back to my dashboard. Hopefully not everything's failing. Okay, so it looks like it's working as expected. So I'm communicating over HTTP via the TCP, and it looks like it's working. Now, if I were to go back to my config and mess with this a little bit, mess with the string message, for example. So one thing people forget to do is to add the escape characters. So what if I do something like this? It shouldn't work. Yep, and all three of them fail. So that's the brittleness of the send and expect directive. You need to make sure that the text and the string message that you're sending is exactly what the backend is expecting. Now, because we're communicating over HTTP, I need to make sure that that message is correct in terms of its escape characters here. So this is going to be, what was it? Cursive new line. And if you're curious what this all means, it's if you were to do a curl-i to your backends, you would see that it's creating all these, it's listing all this information, the connection information on new lines. And that's kind of what those string messages are doing. Okay. So that's pretty much the health check example for today. Now to dive a little bit deeper, we could go to the health check examples that we have on our admin guides, which I list at the end of the course. So TCP, UDP, load balancing. Now let's say some of you need to do UDP load balancing, right? So you have maybe you're doing DNS load balancing, for example. As you can see, with that match block, you would need a really long hexadecimal that you're sending basically to the DNS server, and you would expect some kind of message from the DNS cache or to the DNS server itself. Or maybe you're doing NTP health checks, and you'll need to expect some kind of code back. So that's pretty much how brittle and how specific these fine-tuned health check needs to be. One other thing I want to mention with UDP, which I didn't really show you. Oh, here's if you're doing mail proxies. Where are you? So UDP, where are you? Requires the UDP parameter on the listen port. That's what I wanted to show you, but I'm not seeing it here. Okay, so I'll just make a quick example. So if we were to make a UDP block, which I know this isn't going to work because I've closed it off on the AWS security group. But let's just say, I had some server, blah, 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 .53. I would need to make another server, and the listen port would have to be 53. I would also need to specify that on the listen port. And the reason why is because remember when I said the default port is TCP? If I don't specify UDP, it's just going to assume it's TCP. So it's going to communicate with the default UDP port over TCP, and then you're going to get an error. So make sure you remember that when you're setting up your UDP upstreams. Okay, so that is it for health checks. That was a very quick quick lab. The next thing I want to show you is in some situations, you may have to load balance SQL traffic. That's a big use case a lot of customers have. And sometimes this setup may be perfectly okay. You're using round robin, you're using the default SQL port, you're using TCP, and you're just load balancing all of your read traffic this way. But if you need to do write requests, this may become a problem because you may have uneven or non-matching table distributions. So instead, you'll need to set up some kind of active-active or active-passive cluster to make sure that you have a primary writer instance and then you have read replicas. So then it will look something like this. So you'll have your primary writer, which as you can see doesn't have any parameters. So this is the primary instance that everyone's load balancing to. Then you'll have your backup, which will be like your passive node that's replicating traffic but not necessarily serving responses. And then you'll have your down parameter on your third one. Now the down parameter is pretty much the silent partner to both DB1 and DB2. So it's actually not receiving any connections. It's just kind of like your failover instance in case something goes wrong and you just want traffic to be routed in case backup goes down or the primary goes down and this becomes the new read replica. The other thing to be aware of when you're doing this kind of load balancing is to have your proxy connect timeout to something super low, in addition to having your health check set really low as well, so that in case something goes wrong, you get a notification or it load balances to a different replica immediately. Now, having said that, another problem exists with TCP UDP load balancing. What if you're trying to retain the source information from a client during a TCP transaction, but on the backend server, it logs that it came from NGINX. Again, this is because the nature of NGINX is that it's just going to pass the TCP connection along, and you won't have any information in the packet information because it can't inject like proxy set header and inject the client IP, for example. Now, the intention of IP transparency is basically to conceal the presence of a reverse proxy to the client so that the origin server can observe the IP packets and also observe from where they originated from. So in short, what you're doing here is you're actually concealing the presence of a reverse proxy from the backend. So in short, what you're doing here is you're spoofing the source address of all your upstream traffic by including this transparent parameter here. So proxy bind remote address transparent will spoof the remote address, and you can do this with HTTP traffic too if you wanted to, and it will pass it along to the TCP upstream. However, there is a challenge here with TCP load balancing to correctly handle the connection details. In other words, you'll need to make sure that your egress traffic back to the remote client is correctly handled, because if you're spoofing the source address, it's just going to send it directly to the source address rather than send it back through NGINX to make sure everything went okay. So here's what you'll need to do to make sure, it's kind of complicated, but here's what you need to do to make sure that the TCP IP transparency mode of operation will use the correct methodology in order to get back to the client and also route the response traffic back through NGINX. So stepping through this diagram one step at a time, we have step one, where a client makes a connection to NGINX with the destination. NGINX sets the source address by using proxy bind, and this is the previous example I showed you, which is going to be the address of the upstream server. Sends it to the upstream server, and on number 3, we need to make sure that we have configured the routing table on the upstream server so that everything goes back to NGINX, which includes, on step number 4, removing any pre-existing default routes, and also checking to make sure that our routing table makes sense and is actually passing the information back to NGINX. On number 5, we need to actually configure our gateway with NGINX to forward and masquerade all the traffic back to the client, which involves, deleting any default gateways that we have. And then on number 6, the NGINX Plus server, we also need to configure the tproxy kernel to capture those return packets from the upstream and deliver them to NGINX Plus, which was step 5, and also ensure that we run the IP tables and IP rule commands to capture the TCP traffic on port 80, which is usually what NGINX listens on. So what you can gather based here in this diagram is that its IP transparency is very complicated, and we also get a lot of questions like, well, if I'm messing with the IP tables and the routing tables, why even bother with NGINX? Why not just have TCP connect directly over, maybe you pass it through NGINX and then just with the routing tables and whatnot, just send it directly to the client. That's a valid point. Maybe you don't want to give access to, maybe you don't want your client to, maybe you don't want to mess with the IP tables and stuff, or you don't want to give everyone on your team access to IP tables and whatnot to route that traffic. The other downside is you won't have NGINX to do any monitoring. So if you do serve it directly to the client via IP routing, IP tables, you won't be able to monitor, and NGINX won't know if the response that was sent to the client actually was healthy or not. But in any case, this is how you set up IP transparency. What a lot of customers do that's a little bit easier, and I hate saying that out loud, is they use our competitors' protocol, which is proxy protocol. So this allows you to accept client information, and you can spoof traffic. You can also return it directly through NGINX by using proxy protocol. The only downside here is you need to configure it both on your backend and on NGINX. And then there is a guide here embedded in the slides on how to set it up yourself. So here's an example. I forgot that I had an example. So here's an example of the server that's listening on the proxy protocol. You do need to specify it on the listen directive, much like you do other things like SSL. And the set real IP directive here is actually the address or CIDR range of our external load balancer. So I think that's another caveat. You either need to have other instances of NGINX running in front of it, or some kind of other cloud-based load balancer like ELB or ALB for AWS. And then you're setting the real IP address to the proxy protocol parameter, which is the protocol that's keeping a list of the client IP addresses and port numbers. And then you pass that client IP address from NGINX to an upstream server with the proxy protocol as a variable here. So this is an example of HTTP, by the way. Okay, so I talked a little bit about it earlier with direct server return. Now, the benefit here is you're going to get a small performance benefit by returning those packets directly to the client. Because the load on the load balancer is being reduced, it does carry a number of limitations, like I mentioned. So the load balancer can't see the return packet, so it doesn't know if the response was correct. It can't inspect a request beyond the first packet before selecting an upstream, so its ability to make complex load balancing decisions is very limited. And the load balancer can also not participate in any form of negotiation, such as stateful processing. So like if you're trying to reduce the amount of SSL handshakes and whatnot, you won't have access to a SSL session cache, for example. And then most other application delivery controllers features are not possible with this method, such as caching, HTTP multiplexing, logging, etc. So if you need a really dumb implementation of NGINX just to route the ingress traffic, this should be fine. But if you need more complex ADC features, I don't recommend doing this. Okay, so next section is going to take quite a bit of time. This will lead us probably up into our last break of the day, and we're going to talk about advanced caching here. So just as a quick note, how many of you are enrolled in tomorrow's class, by the way, of advanced caching? All of you? Some of you? No one? Okay, one person, two people, three people. Okay, so for tomorrow, this section is like the last section of the course. So this will be repeated again tomorrow, but this is probably, in my opinion, the most valuable part about advanced caching. And basically what we're going to be doing is we're going to be deploying a really advanced cache tiers to speed up and accelerate the connections to your upstream. So just as a general review of what caching is, caching basically is your client makes a request for a page or your upstream server, and the request is always going to hit NGINX first. NGINX will generate a hash, and it will check in hash if this page exists in memory. If not, then it will basically proceed to the upstream. Now, what that looks like is this is the hash key. It's an MD5 sum. And based on what you set as the hash key is how it's going to generate this hash. So in this case, I'm using the scheme, the host name, and then whatever the request URI is. And this is what the request looks like in terms of the string message. And this is the headers that it's passing along. And this is the actual body of the page here. So based on that information, let's say it's a WordPress site, which is an example we'll use tomorrow. It's going to write the response into memory, save the metadata to memory and then actually write the content to disk. So in other words, NGINX uses a persistent hybrid cache. So you can imagine it writing the data about the data, the metadata, to memory and writing the actual file to disk at the same time. And this is what it looks like. So in memory, it's serving the hash key, and then it's writing the file to system using the same hash key as the name of the file. That way, when NGINX gets another request from that same client, NGINX will check in memory if it has that hash key. It says, I found a hash key, and then it will check to see if that cache file still exists on disks. Now, if it doesn't exist on disk, meaning it expired or something, or it got evicted from the cache, it will go retrieve an updated one. Or if it exists and it hasn't expired, it will serve it directly to the client, which will speed up file transfers. So as a crash course for caching, the way it works is proxy cache path will set the path for the cache. Proxy cache is what you use in your location directive to actually reference the cache that you're going to use. And then proxy cache key is what we use to create the MD5. So again, in this case, this is probably the same key that was used in that last example. We're setting it to scheme host request URI. Now, going over what this means is this is the path to disk that it's actually writing the file. This is the levels parameter. So levels is basically creating the 2-level directory for how it writes the files to disk. The reason why we do it this way is that if you have a 1-level directory, meaning, you know, one directory per client or per request, you're basically having, or sorry, per host name, you're basically having a bunch of reads and writes happening in one directory. Whereas when you abstract it away 1 level, if let's say you have, you know, tens of thousands of concurrent connections to your box, this won't slow down the read and write operations as much by allocating it to a 2-level directory. Then you have your key zone. This is the name of the shared memory zone where you're going to store that MD5 keys. And then this is the inactive parameter, which is what we're using to prune the cache, meaning if something hasn't, if we're using this as an example, if something hasn't been accessed for 5 minutes, you want to evict it from memory. Okay. So cache instrumentation, what does that mean? It basically means you want to monitor the ability or monitor the performance of your cache to see if it's having any kind of errors. So in this case, we're referring to the success of the cache entries and whether or not they're actually being served to the client. So if you see a miss, that means either something's happening with your cache or it was the first connection from that client and it's basically writing to the cache as we speak. Bypass is basically means something, you got a bypass response from the upstream, which means you probably configured this directive on NGINX. Expired usually means that I'm not going to go over the details of cache control headers, that's for tomorrow, but there's a header in the cache control headers that has an expires parameter, and it has like the age of the content. If that header expired, or maybe you set it to expire at that NGINX level, it's going to check the origin server to see if there's been an updated entry. Stale is when NGINX takes control and serves stale content from the cache, maybe because the upstream isn't responding, or it's going to retrieve a new updated content, which actually you'll see updated if that's the case. And then revalidated means it's checked the origin server that everything's been revalidated, the piece of content's been revalidated, and then you have hit, which is the one I hope you see the most. So micro-caching is something you can use for dynamic content. So when you're deploying a cache in a cluster or you're deploying a load balancer in front of some application servers that have dynamic content, micro-caching basically means you're caching everything for 1 to 2 to 3 seconds. And the reason you do this is just to take, especially on peak times when you're hitting a lot of load, like Black Friday type load, this will take a lot of load off the origin servers and it will speed up file transfers too. Because dynamic content usually can be okay with being cached for a few seconds because it's not updating that fast. And the reason you have here is it improves the web performance and it reduces the lag again, or the load on the origin server. Now the drawbacks here is some of the cacheability of the content is suspect. And also if you have a lot of load happening, the spike on the origin server after that cached file expires could be pretty significant. So what are examples of things that you could cache? Like PHP pages from a busy blog website, or maybe an RSS feed, maybe a status page for your Jenkins platform, calendar data, etc. Those are things that you would want to cache. this is what it looks like in the config. Just as a side note, these two parameters here, or directives, are necessary for keep alives as well. So keep alives are another thing, and this is regardless of caching. Keep alives are enabled, or at least client keep alives are enabled by default. But if you're going to enable upstream keep alives, these are the two directives you would need. So in other words, yeah, you would do keep alive 20, and these would keep connections to your upstream alive as well as the ones to your client connection. Okay, we're going to skip this one because I know some of you aren't necessarily interested in caching at the moment, and we'll save it. We'll save it for those of you. It looks like most of you are in the class tomorrow, so we'll save this one for tomorrow. But the one thing I do want to go over today is caching on the cluster. So regardless of whether or not caching is a use case for you or not, this will definitely help you out. Even if you're not using NGINX Plus for these deployment tiers and you're using the open source, this can greatly help you in terms of load balancing performance. So what we're going to do here is we're going to set up a high capacity cache as well as a highly available cache. Actually tomorrow, yeah, we'll set up a highly available cache today. But before we get into that, I want to talk about the model of caching too. We get a lot of questions about why there's no shared disk on NGINX. And we get a lot of questions about this and why NGINX Plus can't share a disk-based cache between multiple NGINX nodes. And it was a deliberate design choice by the engineers because storing a cache on a high latency event-based system could potentially have unreliable shared file systems. And that's not really a good design choice. So that goes into the big elephant in the room. So NGINX Plus is very sensitive to disk latency, or NGINX in general. And that's, again, due to its architecture. If you guys aren't aware, NGINX is an event-based architecture, a lot like Node.js or something like that, although it does operate a lot faster because it's written in C. And it's basically a single-threaded event looping mechanism. And even though you can add things to it that mimic the old thread-based models like Apache, to offload some of these read-write operations, when the file system is slow and cache I/O is very high, NGINX Plus may become overwhelmed by those large volumes of thread and then crash. So maintaining a consistent shared cache across all those instances would also require not only that, but cache-wide locks too, so that if you're getting a lot of load and someone makes a request for the same piece of file or same file type, that it doesn't spin off a new thread for the same operation as one's currently being written in process. So we'll talk more about this tomorrow and what that means, and it'll make a little bit more sense, but that's why we have no shared disk. So now that we got that out of the way, let's talk about the fun stuff. So there's two models. We have a sharded cache, or otherwise known as a high capacity cache, and we have a highly available cache. So the idea with cache sharding and the way it works is the total cache capacity is the sum of the cache capacity of each server. This deployment pattern will reduce the backend trips to the origin server. The reason why is because only one server attempts to cache each client resource. In other words, this is usually based on the cache key that I showed you earlier. What happens here is you don't have multiple independent copies of the same resource on each caching server. In other words, each resource gets cached on a separate server. Here's the fault. Do we hear about reverse? So someone asked a question, do we hear about reverse proxy with Keep Alive D today? Yes, we do. That's the section when we talk about high availability after this. So since we're covering this tomorrow, and for those of you who didn't enroll in the class tomorrow, I'll try to go through this pretty quickly, but because it is going to be repeated again tomorrow. So cache sharding uses a consistent hashing algorithm, and that's how it's able to achieve its fault tolerance. So basically what happens here is, let's say you have 3 servers in your upstream, 3 cache servers rather. You have a red, blue, and a green. It's basically going to distribute all the cache entries by a third, right? And then you add let's say one fault fails, for example. What's going to happen is, because of that consistent algorithm, it's going to keep the keys mapped for those other 2 cache servers, where it only remaps remaps new keys that were lost by that one that died or went down, and redistribute it across the 2 servers. So it's going to redistribute the cache data with those other servers. Same thing if you were to add a new server into the mix. It's going to divide all the cache keys by 4. It's going to retain the ones that already exist, but it's going to make sure it has an even distribution of cache entries to those new to that new server, which in this case would be yellow. This is what the config looks like. So this is open. You could use this if you were open source or NGINX Plus, which is what makes it so beneficial. So you can imagine you have like very lightweight, ephemeral cache instances. Like maybe you're even spinning them up in Docker containers or whatnot and sharing volumes or something, or attaching volumes to them. And this is what the configuration would look like. So you have hash, scheme, proxy host. You'd have request URI. This can be as simple or as complicated as you want to make the hash. And then you just add the consistent parameter at the end to make sure it's going to honor that algorithm that I just showed you earlier. And then, of course, you have the destination of each cache server. So how does this fit in with load balancing? The benefit here is that you can combine your existing load balancing tiers to do this. In other words, you can have two virtual servers run on each NGINX Plus instance, and then load balance the virtual server, which is called the VS in this one, to a local cache server so that you can serve it directly from NGINX. Then the caching virtual server on each NGINX Plus instance listens on the internal IP, which will allow you to forward them to the origin server if it can't get a cached response. This will maximize your cache capacity as well as like not interrupt traffic using your load balancing algorithms as well. Okay, so let's go ahead and set up the cache tier. I want you to SSH into your second host, and I want you to back up any configurations that you have there. Then we're going to create a main file, main.conf file, and I want you to copy and paste the details from your host 1 file into the host 2 machine. You can feel free to change the key zone parameter if you want to make it something unique, but essentially what we're doing here is we're just going to create another instance of the exact same config we have. So let's go ahead and do this together. So I have one instance here, and this is where things are going to get kind of crazy. So this is when it gets really important to keep track of which machine you're in. So I'm going to keep my host 1 in the upper left corner. And I'm going to create my host 2. First, let me get out of this one. I'll just close it. I'm going to get a new window. And it's actually a good idea to get all 4 of these ready to go because we're going to be going back and forth between 4 instances pretty quickly. So this will be my host 2. This will be host 1. And then on the bottom left, I'll have host 3. And on the bottom right, I'll have host 4, or backup master, respectively. Okay, so over here, let me grab host 2. Looks like I'm student 8. And then I'm going to do the password. Okay. So now I'm in host 2. Now we would use normally a syncing mechanism to do this, but I don't want to give this machine SSH access at the moment, so I'm just going to copy and paste everything. And the only thing we really need is the main.conf. We don't need the other files. We don't need the TCP load balancer or whatnot. So I'm going to go into conf.d. Let me make this a little bit smaller. I'm going to open up main.conf. I could do SCP, but I just wanted to make sure I'm showing everyone what I'm copying. So I'm going to copy this to my local clipboard. And I'm going to create the same thing, main.conf. And there we go. Now, I should have created the cache first before I copy that over. So maybe that's what I'll do next. I'll just quit this. And I'm going to copy this cache down here. So in my upstream up here, I'm going to have a proxy cache. So this is going to be proxy cache path /data/nginx/cache. I'm going to set the key zone to cache red. Set it to 10 megabytes. This is just for the metadata, by the way. Set the levels to 1-2. Set the inactive parameter to, why do I have 600 seconds? That's random. Then I'll set max size to 2 gigs. And then down here in the proxy pass, the two things you're going to need are proxy cache valid and proxy cache. So we're going to do proxy cache read, and we're going to do proxy cache. Now what proxy cache valid does, we'll talk about this again tomorrow, is you're either honoring or overriding the origin cache control headers. So I'm going to make sure that 200 codes are okay, or maybe 200 to 399. And proxy cache valid, yeah. And you have to set a time too. So let's set this for 2 minutes. Okay. Now I can copy everything. Okay. The last thing I want to do is make sure that I actually have the cache directory on this machine. So I can go to, what is it? It was data, NGINX. Let's see if it's actually there. Yep. Okay, so there should be a cache directory on both machines. So we go to data, NGINX. Yep, they both have cache directories. Okay, good. Okay, so Giancarlo, you asked what entries were added. Let me show you in a moment. So I'll just leave my config up and let everyone catch up. So I added a proxy cache directive. I'll put that in the chat window for you. So that's added in the HTTP context. I added a proxy cache. This is in the location context, these two. Oh, and the last thing I didn't add is I forgot to add a proxy cache key. So I'm going to do that right now in the server context. And I'll have to do this for both. So with proxy cache key, I'm going to do proxy cache key. And we're going to do scheme host request URI. I'm going to copy this and do this for the other config too. And again, that's what's building the hash.
So when you create one path and you try to use a proxy cache for multiple virtual servers, I got an error that says you can't really use the same path. So does that mean you have to define a different path for each time you do this?
So you used proxy cache. So you had a location like this, and you had it in multiple servers of using the same proxy cache?
Well, I wanted to use a different proxy cache, right? So I tried to create basically. I just use a different name, right? So I use the same path, but I use a different, like, let's say, cache red and cache green. But it was the same path.
You would need to, so that this cache red is only referring to the shared memory zone. So you would need to have a separate shared memory zone for each thing. You could have the same path.
That's exactly what I had to do, but it didn't like the path. It says you can't use the same path for different key zones.
Oh, I see what you're saying. So yeah, okay, that makes sense. That's because it needs to write it. It doesn't want to override any directories that are already there in case the headers are the same.
Got it.
Yeah, that's why.
So that is normal, right? Though I mean that is an expected behavior.
Yeah, it's expected.
Okay.
Okay. What else was I doing? Okay, so someone asked a really good question. So. What is this for proxy cache valid 200 to 399 2 minutes? So what that's doing is you don't want to risk what's set at the origin level. So on the Tomcat server, a Tomcat server will usually have some default cache control headers. Based on the response, you're telling NGINX with that single directive to, I only want to accept 200 to 399 response codes. And those are the only kind of cache entries that I'm going to allow. Everything else, I'm not going to cache. That's basically what that line means. And you're only going to keep it valid for 2 minutes before it needs to go revalidate to see if it's been changed. Does that make sense, Giancarlo? Okay, cool. So as you can gather, host 2 is not that important except to be a replica for host 1. So it should have the exact same stuff as your configuration here. And thank you for pointing that out. Yeah, I haven't uploaded, or I haven't reloaded NGINX yet, so I don't know if there's any errors or anything. So thank you for pointing that out. Someone said max size was missing the equal parameter. Okay, I'll fix it up here too. So maybe as a recommendation, test this before you copy it over. And we didn't set up a dashboard for our second host. You can if you want. But just to make sure this is working, I'm going to go to my dashboard, and I should have a cache tab now. Okay. So this is the cache, and this is pretty much what it looks like. So we haven't hit it with any requests yet. That's why it's in its cold state. And if you go to the shared memory zone, you'll also see how many memory pages are being used. And you can kind of see that even with a small memory size, like 10 megabytes, it can take up to 2,544 entries. And now that's not necessarily how many files it can cache on disk. That really depends on your disk size. But this is just showing you how many entries it can take before it will start evicting things. You can also see the max size of the disk size. So this is up to 2 gigabytes. And it will also log your disk usage too. So when you're hitting your upper limits, it will also evict content too. And if you want to test it out, the easy way to test it out is to just, you can either hit your website here and check your cache dashboard to see if it's serving from the cache. So it looks like one was written to the cache. And if I go back, it's writing different pages because they're different pages, obviously, but let's hit this page a couple times. Looks like it's maybe not working. Yeah, if the cache is working, we should see the same loading, the same landing page. So that tells me something's not working. Nothing was written and everything was bypassed. Let's check the log file. One other thing we could do here is we could instrument our cache. So what does that mean? We changed on host 2. We haven't changed anything. We pretty much just copied everything from host 1. The only thing we added after the fact was proxy cache key, which is right here. Let me try and see. So what I'm going to do is instrument the cache just to make sure it's working correctly. And just trying to look to find it, what the actual directive is. Okay. Okay, it's not here, but I'll just do it manually. So what we can do here is I'm going to add the header and the response just to make sure it's working correctly. So I go to vim main.conf. And I do add header. Just going to look it up really quickly. So it's X cache status. It's a special header. So it's X cache status. And then you want upstream cache status. So that's going to add the header in each response. So after I do a reload here, and then I do curl-i HTTP localhost, I see that it's a miss. Okay, so something's not working with my cache. That's why it keeps missing and missing. And I want to say it's something I did wrong with the configuration. And oh, I think I know what it is. So when you define your proxy cache path, it's always a good idea to do it this way. So you do levels first, then you do your key zone. Key zone cache red. And I have main active in there. Okay. Let me check everything else. I'm also going to set this to any. Okay, now it's working. So I had the proxy cache path directive incorrect. Okay, so let me go ahead and pull this up for everyone, and I want you to copy this for both of your hosts. So basically this here is going to go in the chat window. So that's your path, and then down here, you're going to have this in your location. And then you're going to have this one in your server. Okay, so I'll go ahead and update that on my other host too. So the reason why you have to have levels after your path is it needs to know the hierarchy of how it's going to write content to disk before it can write, before it defines the memory zone. And oh yeah, thank you for pointing that out, Giancarlo. So also, if you want to check the status of your host 2, you could do this one as too. That was just for troubleshooting, but if you feel like adding it, feel free to do it.
What does add header again does?
It's adding the response, the cache control, the cache status response header in the response to the client.
Okay.
So from a security standpoint, I don't recommend keeping that there so that your clients can access it. But for troubleshooting, it should be okay. And I'm going to try to show you the whole thing. There we go. Okay, so let's give you guys a few minutes to work on that. And this was probably the hardest part, honestly. Everything from here out will be pretty smooth sailing. Fingers crossed. When you do make your changes, don't forget to reload. Because as you see there, I had a problem. So let's go. Key zone, not key zone, key zone. Giancarlo, did you have a question, or was that the one you asked in the chat window?
No, we're good for now.
Okay. Martin, did you sort it all out too? Okay. Okay. Does anyone need any more time, like a minute or two? One more minute? Got it. Yes, Martin, I will have a video after the training. It's going to be on Vimeo, and you'll get the link probably sometime tonight. And you'll have it forever. It'll just be password protected. As far as the instances goes, however, you guys will only have these instances for the next, I guess, like 24 hours. So basically, it'll be these will be taken down by tomorrow. I think it's tomorrow afternoon or something like that, or tomorrow end of day. So feel free to go back through the lab exercises up until tomorrow, and then if you have any questions regarding how to do this locally, like with your own instances and whatnot, feel free to shoot me some emails, and I can help you out. There's also some really good admin guides embedded in the slides too.
Does the proxy cache directive, it doesn't matter if it's located at the server level, or does it have to be done at the location level?
If you do it at the server level, you're basically telling the server to cache everything regardless of the location URI. It's just kind of like a best practice to set it for a particular location. And it won't actually cache anything if it's not proxy. That's why I put it in that location where the proxy path lives.
But what if I have multiple locations and basically I want to redirect it? You know, I don't want to cache everything.
Yeah, then I would put it in the server block.
There's no impact on the performance, right?
Not really, as long as you've set the. Well, you have to set the proxy cache directive to. It's going to cache it all in one memory zone in one path. That's one. Right. That's one use case for doing a different one. I think that's what you were talking about earlier, using a separate memory zone and separate path per location. But if you didn't care, yeah, you could just create one giant cache path and just set it at the server level.
And what's considered to be the, like the max size? What's the optimal max size?
I wish I had a hard number for you, but definitely not your entire disk. So maybe like 50% or something like that. Well, if the disk you're using or the machine you're using NGINX for, or whatever resource, hardware resource, if all it's doing is proxying and load balancing, then yeah, you could use most of the disks, like 70% of it or whatever.
Yeah, that's all I'm using them. I'm doing a reverse. I got two HA instances, one for reverse proxy, one for load balancing.
Yeah, you can set it to a pretty high value of whatever mounted volume you have on there. You could also have, I would just allocate some of the space for session data, temporary file storage, buffer data, so you don't use the entire disk, but feel free to use as much as you want.
Okay.
All right, so let's go ahead and move on and test this. But before we do that, the next thing we have to do is SSH into our other instance, which will be our master instance. So let me open up a new window, drag that down here. Looks like we already did that. Okay, so with our upstream server, which is going to be master, so we're gonna, this is going to be like our new load balancing instance. So we're gonna SSH into master, and we're gonna create a file called proxy.conf. So in your upstream server, or your master server, sorry, I keep conflating the terms here. Mine's going to be student 15. This will segue really nicely into our keep alive D and high availability section. Okay. So I'm in my master instance here. I'm going to go to the default NGINX directory. I'm going to remove the default because I don't need it. And I'm going to do proxy.conf. Now this is going to be a really simple config. It's really just going to be everything you see here. In fact, I could probably just copy and paste this and we'll be good to go, aside from, I need to change the entries here. So with this is going to be my host 1 entry. Yeah, let me do that. Although the formatting is going to be crap. I apologize. Okay, so here we have my host 1 instance. This is going to be my first cache server, basically. And then the second one is going to be host 2. Which is the second cache instance. And before I do this, I actually want to make sure that this cache is working too. It's probably a good idea. So let's do add header x cache status equals upstream cache status. And let me go ahead and reload it. Some latency over here. Grill-i http localhost miss. Okay, I knew there was something going on there. I think I didn't make the same change I did up here. That's why it's not working. Could also be, yeah, it could also be the way I set up my proxy cache valid. So we'll just set this up to anything. It's Tinky? Okay, yeah, I'll change it. How is that? Much better? Oh, tiny. It's funny. Okay, so let's double check this cache, just make sure it's working.
And what's the upstream servers you're using? Is that the just the regular upstreams?
Yeah, so this is the one on the left up here, and this one is this one on the right. So these are the two. This is host 1. Here, actually, maybe I'll comment them to make it.
Which one is the master? Where's the config in the master?
The one on the bottom is my master machine, and my upstreams here are host 1 and host 2.
I got it.
This is not a this isn't an active passive cluster. This is just like round robin, 2 upstream cache servers.
Got it.
And you'll notice from the I'm using the sharded algorithm, so I'm using the scheme, proxy host, request URI, and the consistent algorithm. And really all I'm doing here is passing the request through. Okay, so I know you guys are still working on that, but once you're ready to test, and if you feel like it, you can also create a dashboard.conf again. This will be a good test for you guys to make sure you're paying attention. So you can do a listen 8080 location / API. I'm sorry, my tabs are off. Location equals / dashboard.html. Root user share NGINX HTML. Okay. Do a dashboard. Okay. So now what I'm going to do is go back to my browser, and I'm going to go here, and instead of using so this is actually my host 1 cache, but instead I'm going to take my master node. I'm going to go to 8080 and then go to dashboard. So now this is showing my cache servers. So these are the cache servers. So I can actually see which cache server is going to be serving the response here. And to test, what I recommend doing is to run this command, obviously with whatever your IP address or host name is of your master node, and then run it in your like a local terminal or in a separate terminal. So let me go ahead and set that up. So I can open up another shell here. I'm going to need it anyway in the next exercise. Tiny. There we go. So, oops, forgot the semicolon at the end. So as you can see, I'm getting 200s here. If I go to my dashboard, check it again, I should be getting equal amounts from both cache server. So this is pretty much like, it's a dynamic request. And it's basically serving it from different cache servers, and that's why you see the requests are being divvied up using round robin. And then if I go to my cache server, go to refresh here, looks like the hit ratio hasn't even like kicked in yet. But it does look like it has served a lot. Oh, actually it looks like it's bypassing the cache. I guess that makes sense because they're dynamic requests. But it is important to recognize that if something were to happen with my cache server, like let's say I stop the NGINX service on this one. So if I go sudo nginx-s stop, for example, while I'm running this command. So let's say I stopped it. I'm still going to get traffic working. It's still going to serve from that cache server, and it's going to cache all the remaining responses. Well, if it wasn't a dynamic request, it would, but if it was just like a normal for loop without any dynamic capabilities, it would cache the responses. Okay, so someone had a question. Can we see the main.conf for master when you get a chance? Yes. And then I'll post the command that I used. I'll just take out my host name and let you put in yours. And Martin, you had a question? Oh no, Martin was just making a comment. Yeah, I should look at something else to divvy up my terminals. You're right. I used to have a, what was it called? Was it iTerm or something else? Where I had a really easy way to do that, but yeah, iTerm 2 is probably what I was using in my past computer, but this is a newer computer. And I'm lazy and I haven't downloaded anything yet. Tmux? You recommend Tmux? Yeah, I'll have to look that up. Oh yeah, I've seen people use this before. God mode. Cheat code: up, down, left, right, start, select. So I think we can do one of two things going forward. We can, after you guys get this up and running, because it's actually more important for the next lab, we can take a quick break before our next lab. It's about 12:15 already, and this will be our high availability lab, where we basically implement KPLAB-D, and then you'll allocate an elastic IP address based on the health of the node. So we can take a break, or we can power through. It's up to you guys if you want to power through and try to end a little bit early. Okay, I got 1 vote for a break, 2 votes for a break, 3 votes for a break. Okay, let's take a 10-minute break, and then when we come back, feel free to keep working on this. I'll keep my configurations up, or at least I'll keep one of these up for the proxy cache path. Let's come back at 12:25. And then we'll work on the last exercise and call it a day. Sound good? Okay, so we did the sharded cache. The next thing we need to do is talk about the high availability cache. So we're not going to actually do this one today. For those of you who registered for the class tomorrow, we will set this up. But the general idea here is if minimizing the number of requests to your origin server is basically the primary goal, then cache sharding is not the solution. Instead, you should have something that's carefully configured to have a primary and a secondary cache. So with this model, you're basically, the request is hitting a primary node that's going to forward the request onto a secondary node. It's going to cache the response from the secondary node, which is the secondary node is also caching from the origin server. So that we have like 2 copies of the cached entry before it needs to go to the origin server. From a configuration standpoint, it's pretty simple. You just have your primary cache is going to the secondary, and then the origin is a backup. And then the secondary only has 1 upstream in it, which is basically the origin server. So we're going to skip this lab, But to talk about the failover scenarios, you can feel free to do this, by the way, on your own time. But if the way it works is there's two primary failover scenarios. So basically, the primary cache will fail. So if you like drop the IP tables or maybe you shut down NGINX, the HA solution, which in this case we haven't set it up yet, but it would detect that there's a problem with the primary cache, and it would allocate your VIP to the secondary cache, which would then forward onto the origin server. If the secondary fails, it's okay, because in the primary configuration, you've already set the origin up as a backup anyway. So the primary will go onto the origin and then cache that response, which will then serve to the client. All right. So talking a little bit more about caching, this method called the hot cache basically utilizes keep alive D for high availability on that first level tier you see there. And then on the second, the second tier behind it is basically something like we set up, like a cache, a sharded cache. So this is what I like this method, because on the load balancing HA pair, you could basically set up a really, really short micro cache. So this will be like your hot content. And then on the secondary cache, you can set that up to be a little bit longer. And then you can also scale that out to as many cache VSs as you need to serve static content. And then, of course, this will drastically reduce the load on your origin application servers. So this is kind of like an advanced scenario, combining the best of both worlds. Now, when you are timing your cache updates, make sure that your expires header is shared by the multiple instances. So this is something you may want to keep track of in making and having some kind of configuration management tool. So we do have a sync capability that we'll talk about a little bit, but it's recommended to shorten the expires header so that you don't have any timestamp mismatches. Okay, so last section of the day we're going to talk about is high availability. Particularly, we're going to talk about the Keep Alive D solution. So the Keep Alive D solution uses VRRP. And it also, we have already enabled session affinity, so that's really good. And we're going to talk about how we're going to deploy this with the machines that we have, as well as some cloud solutions that you may want to explore too. So the general steps to configure HA is we need to have 2 NGINX nodes. We need to have, actually this is optional, but I definitely recommend it, and Alex can probably attest to this, that this is really good if you need to share your configurations with your other nodes, especially if you're using sticky nodes.
Yeah, big time recommend it.
Okay. Now, I'd say the only downside with this is you have to give SSH access to your nodes, but you know, if they're behind a firewall or a WAF, shouldn't be a big deal. You'll need to make a base config and then push the configs using NGINX-sync. And then basically after that, after you have all your configurations on all your nodes, you'll need to configure Keep Alive D, which is going to assign your floating IP or VIP to the master node. And then, of course, you'll do some testing. Okay, so today we're going to set up active-passive. As extra credit, I recommend everyone try to set up an active-active node, after class. So definitely look at the admin guides that are embedded in the slides and see if you can set up the active-active node. But basically what we need to do here is we need to modify our master proxy.conf. We're going to pass some headers. We're going to turn the access log off just for performance sake. And that's really all we need to do in terms of modifying that proxy.conf. So what we're going to do here is, and let me set this up. Okay. So over here, and I know my tabs are off again, but I'm just going to add those headers. Set header host, proxy set header. And the reason we're doing this is if you want to log where the request came from, or you want to check the logs on host 1 and host 2, you can do that, and you'll see where it came from. Proxy set header. It's also very important for the forwarded for header so that you know NGINX has a full list of all of the addresses that are being proxied through this HA pair. Okay, so that's really all we need. The next thing we're going to do is, actually I'm going to skip this, but I definitely recommend doing this when you're thinking about moving to prod, is making sure you have a master node and all your peers or whatnot that you're using the master as your 0 point of truth, and that you're syncing all your configs with your master nodes. Now, you can do this in your own script, or maybe if you have a CI/CD cycle, which is one thing we don't have set up right now, maybe you have something that's pushing all these configs via every merge or request or pull request. But whatever the examples are, once you configure it, when you run that script on the master node, it's basically going to define conf paths using env variables. You're going to exclude any confs that you don't need, like maybe one you're using for dev or you're testing out. And then you're going to give either the DNS or IP addresses of each of your nodes. Okay, so this is the steps if you wanted to do this, but I'm actually going to be super lazy because we only have one node. I'm going to just copy and paste it. And okay, so I'm skipping all that. Okay, so rather than do that, I'm just going to copy and paste it over here. So let's make sure that I get into my backup node. So now we're going to go into our backup node. And I need to pull that up. The other reason why I don't want to, do this in front of you is so that people don't hack my machine and see the SSH keys that I'm generating. Okay, so let's go into my backup node. Get my backup password. And then I'm going to basically create the same file that you see on the bottom left, which is called proxy.conf. And I'm going to copy everything I have here. And there we go. So let me go ahead and reload it. I'm actually going to reload this too because I haven't yet. While I'm here, I might as well just reload everything. Okay. So moving on to high availability. We've already done all the NGINX stuff. If you missed that, all I did was I SSH'd into the backup node. I copied proxy.conf. So basically the bottom two configurations match and the top two configurations match. So this is our HA pair down here at the bottom. Up here are our cache tiers, so our cache servers. The next thing we need to do is we need to set up high availability. So as cool as this is, these two instances are not aware of each other. So what we need to do is we need to set up keepAliveD, which is a separate process, which will define one is the master and one is the backup. And the way it works is we use the open source project keepAliveD, which is basically a daemon that you use for Linux servers. And it uses the Virtual Router Redundancy Protocol, otherwise called VRRP. And this is what it does to manage our virtual routers, which in this case are our VIPs. And it also creates a health check facility to basically determine the health of my service. So in this example, it's monitoring the health of my NGINX instances. That way, if a service on our node goes down, it can configure the number of health checks, what to do with the VIP if something happens, and it also ensures that there is a master at all times. So similar cloud solutions for this same type of functionality is, you have your Google Cloud Compute, you have floating IPs for other cloud providers, and then AWS has other mechanisms like DNS, Elastic IP. You can also use an ELB, or I think it's called ALB now, for your load balancers. But this is pretty much if you're doing everything from scratch yourself. So NGINX actually has a pre-built binary and also a pre-built implementation with keepAliveD that you can pull down. It's pretty much just like sudo apt-get install or yum install nginx-ha-keepAliveD. And this basically provides some scripts that will help you manage the VIPs as well as the master and slave apprenticeship or designation. It also comes with a script where you can designate advertisement message, which I'll dive into in a little bit. And here's the quick start guide for it. Basically, you install the package, run the setup. You can configure the health check script manually if you want, or you can just go through the quick start setup guide. There's also some admin guides and controlling mastership guides here embedded in the slides. And if you are going to do that extra credit for setting up active-active, I definitely recommend going through this. But again, you will only have these machines till about tomorrow. So if you're going to do it, tonight would be the night to do it, or tomorrow morning or something. So VRRP, what does it do? It basically ensures that there's a master node at all times. That's the big takeaway. The backup node will listen for those advertisement packages from the master node, and if it doesn't receive whatever, I think it's 3 by default, but you can basically set it to whatever you want. If it doesn't receive 3 consecutive advertisements from KeepAliveD from the master node, it'll say, okay, master must be down, so now I'm going to become the master. And that's pretty much how an active passive setup works with VRRP. Now, in terms of the KeepAliveD configuration, describing the entire config is probably beyond the scope of this class, but there are a few things worth noting. So each HA setup needs its own copy of the config file, which with values of priority, unicast, source IP, and a lot of the ones I'm going to go through here. But the unicast source IP is basically the IP of the interface that KeepAliveD is listening on. So KeepAliveD, again, runs as a separate daemon than NGINX, and that's pretty much what this directive is defining, the IP of the KeepAliveD instance. Unicast peer is the IP of the peer instance of KeepAliveD. So this would be my backup node, for example. Now, priority is what we use to define which host is going to become the master, which I'll explain a little bit more in the next slide. The notify directive is basically the names of the notification script. So this is the actual health check that we're going to run during a state transition. And then finally, the VRRP instance is basically, it gives us high-level details about the environment. And then the virtual IP address is exactly what it sounds like. It's the actual VIP that's going to be floating around and we assign to the nodes. So here is an example of what the script looks like. In this example, we have the value 51 for the virtual router ID. Now, the V1 block, as you see there, VRRP instance V1 block, that's a sample value, and it's basically unique to each environment. You can also have the value of your VIP, which will be often a float-in IP address. It can have multiple VIPs for this environment. If you do have multiple pairs of KeepAliveD instances, like other VRRP instances running on the same machine, for example, or in your local network, you can create a block per VRRP instance. And this is kind of a clue to get you how to set up an active-active cluster. Okay, now when you're defining mastership, one thing to note is that there is no default fencing mechanism in KeepAliveD. In other words, if the two nodes in a pair aren't aware of each other, they're both going to assume, "Yay, I'm the master." So it's very important to make sure that you make sure that each node doesn't keep constantly trying to assign the VIP to itself. So to prevent it, the NGINX KeepAliveD implementation comes with a script execution mechanism, and one of those is check NGINX service. So that's basically checking the local VRP node to make sure that it's okay. Wait is what we use to add priority. So it's expecting some kind of return code, and we usually use it in increments of 10. So in this case, if you were using our last example, 1 was 51 and 50, 0 would return something ending in a 0, in other words, would basically indicate a healthy return code. And then interval would basically be the time in between the health messages that it's going to actually check it. Rise is kind of like a passes, and then fall is like a fails. Then you have, okay, so this is an example of what it looks like. So we have check manual failover. This is checking this is if you wanted to run it manually, and this is the one that's running automatically. So it's doing the same thing essentially, but this is a longer check. Adding more VIPs, again, the initial HA script is pretty basic. It makes only a single VIP highly available. If you want to add multiple VIPs, you can just add them in the virtual IP address block. And this is another clue to how you would set up an active-active cluster. So another thing worth mentioning is the KeepAlive daemon uses the syslog utility for logging, which also makes it cool and flexible that you can actually log these to an external server too, if you're doing centralized logging. On CentOS, RHEL, or SLES-based systems, the output is typically written to, I think, var log messages, and then the ones we're using, like Ubuntu and Debian, it's using var log. So this is an example of what it looks like. during a state transition. So here you see we have keep alive D, it's monitoring everything, and then you can see that it's transitioning the state to backup because it received 3 failures. And then it's basically forcing that new master state election. This is what it would look like in the logs. So cloud solutions. What if you don't need to use keep alive D and you already have a cloud or VPC set up? How do you achieve HA with NGINX? A couple options you have are floating IP. You can use the Google Cloud Environment's active load balancer, which is a lot like AWS's ELB or ALB. With AWS, you have some other options too, and there are Google equivalents for these as well, but you can set up DNS routing, or you can set up elastic IPs, which are pretty much like VIPs. And this is how they work. So in the slide, I'm not going to go over each of these, but in the slides themselves, there are embedded links to how to set these up, each of these, if you wanted to. Now, this one is like the most complicated way to do it. It's kind of like the way things are heading with serverless architecture. In other words, you're using function as a service to assign a VIP. I don't think there's actually a guide currently for this one. This is something you'll have to elect NGINX Plus's professional services to do. But if you're clever enough, you can follow the instructions here. And if you know a little bit about Lambda and API gateways, you could probably connect the dots and try to do it using this method. Yeah, so I'm not going to go through all these, but if you check out the PDF, there's examples and disadvantages and advantages of each. And the guides are embedded in the slide themselves. Okay, so let's go ahead and set up Keep Alive D. Make sure you have your master and your backup ready to go. And I actually recommend doing these steps one at a time on both machines. So if you see, so each step, do it on each node. So for example, I'm going to go to user bin, and then I'm going to go over here on this one and do the same thing. So I'm going to do user bin. And I'm actually going to clear this up here just so so it doesn't look cluttered. Okay. So we're in user bin on my master and my backup node. Are you guys still with me? I don't want to lose you if you guys are not paying attention or something. Still here. Okay, good. Didn't lose you yet. Okay, so now we're going to run the HA setup script. So I'll do it in this one first. I think I do need to use sudo, unfortunately. So I'll do NGINX HA setup. I'll do the same thing over here. Okay, I'm actually going to move this up a little bit. Yeah, I'll move this on up too. Okay, so this is basically telling you that this script is basically used for Debian, RHEL, CentOS Ubuntu-based system. It's going to actually configure the highly available NGINX Plus environment for you, but it's going to do it as an active passive. And it does say the requirements are you need 2 running systems and 1 free VIP, which is going to be our cluster VIP. So we'll just go ahead and hit enter here, and to enter on both. So it's going to detect the IP address here, actually. Let me go ahead and move this up because this is bothering me. Okay. So it's going to say, oh, I found the IP address. This is the primary. So this is your node, your primary node. I'm going to copy this one. And I'm going to go, yes, I want to use this one. And it says, please enter the IP address of your second node. Now I can just go over here, copy it, because I know this is my slave node, paste it there. But before I do that, I want to go over here and go, yes, use this one. And then this one's going to say same thing. Oh, please paste the primary node. So then this is why you do this at the same time, by the way. And then you go over here and you post it, and then you go enter. And then over here you go enter. So I go yes, and then I hit yes. Hit enter to continue, hit enter to continue. Okay, now it's going to ask you for your VIP, or as this says, the cluster IP address. Now this should be in your sheet that I gave you. Use the IP address, don't worry about the allocation ID quite yet. So for your VIP, let me see if I can find mine. I hope you guys all have your VIP. If not, I have it here on the sheet. So we're going to enter this twice for both scripts. So we have one here and one here. I'm going to do it on the primary first. It's going to ask, is this correct? I'm going to say yes, and then back here I'm going to do the same thing. It's going to say yes. Now this is very important to not mess this up. So it's going to ask you to define mastership right now. So I'm going to say I'm going to type in number 1 for my master, and then I'm going to type in number 2 for my backup. And then it's going to start the keep alive D daemon. And as soon as I hit enter, it's going to start checking the health of each of these nodes. Now, if you want to test this, the easiest way to test it without actually, like dropping the IP table and, reassigning the VIP in real time is you can just check the state file. So basically what we're going to do here is I'm going to cat var run NGINX HA keep alive D dot state, and it'll tell me, okay, this is state equals master. And then I can do the same thing over here. I can do cat var run NGINX HA keep alive D dot state, and this is going to say state equals backup. All right. And let's say I stop this one, for example. Let's say I stop the keep alive D service. So let's say I stop it on the master node, and I go service keep alive D, and then stop. If I wait like a second or two, and you can see right away that this is already transitioned to the master. Now the problem is if I start this back up again, I don't believe it will reassign it. And that's because we haven't set up the script to do it. Oh, it did reassign it. Okay, good. But we haven't publicly exposed the Elastic IP yet. Once we do that, I do want to warn you that you're going to lose your DNS name. So be careful. You can also curl your Elastic IP as well. So if you want to curl, I think I still have it saved to my clipboard. Yeah, you can see that it's actually going to the Tomcat instance, which is good. And actually it looks like it's stuck to number 1, which is good. So it's serving it from the cache, as you can see, serving it from the cache, which is why it's not load balancing on that home page.
Can I point something out?
Sure.
When you set in these keep alives, make sure that both active and a passive node have the VIPs correctly identified. So if you have more than one VIP, it's going to start throwing an error, and you're going to have all kinds of wonderful trouble.
Oh, you mean if you put multiple VIPs in that VIP block in the virtual IP blast? Yeah.
Yep, make sure they're always in sync. Otherwise, they'll start throwing an error without really notifying anyone.
Right.
And then when you try to fail over, it's going to crash.
Oh, fun.
Speaking from experience.
Okay, thanks for that tip.
Yep.
Okay, so I'll give you guys a minute to do that. The next phase in the lab before we leave, and this is totally optional, which is why I leave it to the end. We can actually edit the script to do a public test. Now, again, when you do this, you're going to lose your DNS because the way AWS resources work is when it's going to allocate the IP, it's basically going to, those ephemeral public DNS names are going to go away, and it's going to reassign them. So in other words, you'll lose SSH access. And I may need to actually tell you what your new DNS is. But anyway, if you wanted to test this, go ahead. It does require, you would need to change a little bit of the permissions for the notifier script, or maybe you don't. I can't remember if you do or not. And you would basically need to put in your master private IP, which if you're not sure what your private IP is, it's this. This is your private IP. And same would be over here. It's also what you entered as well in the script too. And then you would also need the allocation ID, which is also in your sheet. You could also curl your Elastic IP as well, I think publicly, and it would work. You just wouldn't have the DNS name anymore. Okay, so because that's optional, I'm going to skip it for now, but I will actually show you the script before we move on. So let's see if I think it's in user lib keep alive D. Cat NGINX notify. Yeah. So this is what it looks like. So here you can see we have a path file, we have the state file, we have keep alive D, and oh, maybe this is the wrong one. Yeah, this is the wrong one. Which one am I looking for? I'm looking for check. Maybe not. Sorry, just kind of trying to check this out. Nope, that's not it either. Maybe they changed the format. It used to be a little bit different. You used to be able to add the HA nodes. I think I'm looking at the wrong one, maybe. Huh. Maybe it's in Etsy. Okay, well, it's not that important. But there used to be a script where you could add the HA node 1 and HA node 2 and also the allocation ID. But I'll take a look for it in a couple minutes, and I'll email everyone when I find out where it is. But it is on your machines, and we can deal with that later because it's about time to end for today. But one thing I want to show you is I do recommend doing this on your own time. So setting up an active-active cluster. Again, both nodes have, in this case, there's two options. Both nodes have their own VIP and state equals backup. This is, again, you have two blocks here that are two separate environments. And this is the tip I was giving you earlier on how to set up active-active. The other thing is you need to decide how you're going to handle it on the NGINX end. Either you're going to have one VIP per server, or you're going to have both. Any VIP can be used by any server. You just need to use DNS to route that the VIP assignment correctly. And this is kind of what Alex was alluding to here, that you could end up with problems with VIP allocation and that you won't really know what's going on. You'll just get errors thrown back. And then because of the NGINX check notify script, it's going to crash your node. Okay, also there's an admin guide to do this in the cloud. I like Google Cloud. I also like AWS, but this one's a little bit simpler to set up. And I would argue that Google Cloud's GUI is a little bit better than AWS is. So if you want to set up a cloud implementation of everything, you can use GCE's network load balancer, and then this will give you a full active-active plus sticky sessions cluster. So that's pretty cool. And then you can probably try to reverse engineer it to get what you need it to do in terms of on-prem deployments too.